and dots and stuff will shoot at me. I'm giving you guys the information on what I found, what you will find using these particular scopes that we're covering. Does that make sense? So I'm going to go over that again. So you let me know, Rich. Okay. Thank you for coming out for the TST, getting the most out of your Labscope seminar. Tonight we'll be covering Modus, Genesis, Fluke 98, Fluke 190 series, Pico, and EScope. On all of these scopes, I'm going to give you some tidbits of information to use, how you can capture stuff a little better, find out where you have a problem, contrary to belief or what's in some Labscope material. The other thing I'm going to tell you, if the vehicle is a hybrid, some of these units you cannot use, okay? And I'll tell you the ones you can or cannot. To use them, the vehicle itself puts out a high voltage, and the meter/scope in this case would have to be Cat 3 certified, including the leads. If you did not use that precaution, or if the unit can't handle it, you could be seriously injured. So I want to make sure that you see I'm just telling the truth. It's not my fault what a manufacturer did to produce something or not produce it. I'm just leading you in a guided path. Anything else I say is my opinion of the particular scopes, okay? Whether I like them or dislike them, they all have a lot of pluses. It's nice when you have all of them. I use all of them. Sometimes you want to pick up one more so than the other. If you remember an article last month in the newsletter, there was one scope being used, and there was someone's information system being used right in it, which is another /scope. That was an article that someone put in there, right? So just keep that in mind as we go through. How many people here, before we get going, actually use a Labscope at least once a week? Okay. How many guys got Modus? That's what I thought. Okay. By the way, that's my findings. That's why we start out with Modus. More people have the Modus than anything else. Genesis. Not many of you guys will blast through that. Okay. How about a Fluke scope? Tektronix, a lot of Fluke. Any Tektronix scopes or Max scopes? Okay. Got a couple of those guys. Truglia, MT25, 5200 or 5100? None of those? Good. And EScope. Oh, there's Gary. He's not here with Pico to harangue me? Okay. All right, so we'll be covering a lot of these, and I'll general things when we don't cover it. LS2.0 getting around. It was a pretty good scope in its day. We'll talk about limitations. It still could be used for non-hybrid stuff, so don't think you can't use it. So here's all the different scopes we have in the training center, and you can see I get to use a lot of different scopes, all from a box-type scope like the EScope there. Is a nice little 2-channel Pico box, basically. The Fluke 190 series, Interos that we're not going to talk about much anymore. You know, I had a couple of guys in the classes the previous nights that had them. 4-channel scope, 20 megahertz. My old Tech 222 or 224 scope, good scope, could see it across the room, but has limitations. All the rest of these scopes here are 2-channel scopes. Perception. Not a bad scope, especially if you got a brain fart. And we'll talk about a guy that actually put that scope together, and something that I was using before that had to catch a dropout in a signal. A lot of times you guys look for 1 to 2 complete signature waveforms. We'll talk about what that is in a minute. You could sometimes get lost finding a problem. So I'm going to give you some bits of information like that scope uses. The UEI updated version of the snap-on unit, the old Fluke 97, Fluke 98, the Modus, the Vantage Pro, the Pico, the 8-channel EScope, the only scope here, by the way, with 2 time bases. So that's a big difference. Every other scope we're going to be talking about, 1 time base, maybe 4 voltages if it's 4-channel, or maybe just 2 voltages, but 1 time base. You'll see where that may or may not come in handy. Power probe, must have a power probe when you're starting to use the scope and stuff, because you can do a lot of things with it. And a good amp clamp. That happens to be a picture of an ADI-110, although there's a lot of good ones out there nowadays, less expensive. Those are about $500, high 4s to 500. You could buy a PDI unit. One of our sponsors in the back, AES, sells them for about $125. And you could use them on any scope. So let's first look at what a scope is about. And let me talk about this. You can see that we're dealing with voltage and time. True scopes do something called voltage per division. division. Meaning, each one of these little boxes, as we go up this way, we count in voltage. As we go across, we would count in time. So your newer scopes have a little bit wider screen. Rather than 10 boxes going across the bottom, they may have 12. Rather than 8 going up top, they may have 10. They did that to give you a little more resolution. Now, here's the important part. When you look at a scope, and we're going to make believe this is the bottom line of it, I always like you to use this as your 0 first line, one above the bottom. Okay? So when I'm looking at that chart there, I'm talking about using this line right here, not the bottom, this line. Everyone with me? The reason being, you ever have something that goes underground, and if you're all the way on the bottom, you're not going to see it. So always lift it up at least one division. Some scopes don't, like Pico, what do? They do voltage and time per screen. That means the whole screen is X amount of volts or X amount of time. For argument's sake, if I'm on a Modus and I want to look at a fuel injector, my voltage is going to be set at 100 volts. Why? It's going to give me the whole screen so I can see the peak. If I'm on a Fluke scope or a Tektronix scope, I'm going to be 10 to 20 volts per division. So I could count it up, 10, 20, 30, so on. Okay? So let's look here. If that's my 0 line, here's my other line, here's the next line, and you all know what the signal I just drew there is, right? If not, this is a fuel injector. This is all voltage coming in. Looking at this signal when I have it up on a scope, I'm not only looking at the fuel injector signal, I'm looking at something else here right away. What are we going to be looking at? Where the voltage coming in is. How about if I had a voltage drop? My charging system, if this is 10 volts and that's 20 volts and it's somewhere in the middle, I know roughly I have some voltage out there, correct? So that's the first place I'm going to look. The next place I'm going to look is that the line is not going straight across, but it is going to ground. If it doesn't go to good ground, we may have a driver problem. We may have a poor connection, a voltage drop. We have made something going on. You need to check that out. Does that make sense? Okay? So we like it to go all the way down. If it didn't go all the way down and it went somewhere above ground here, what's going to happen to that fuel injector pattern? It may still look the same, by the way. What's going to happen to the fuel delivery? Not going to be real good. Okay? Not going to be real good. So, excuse me, if you have that in mind by looking at this, that's key. Hey, we went to a good ground. We have good voltage going in. How about this line right here? Called the peak. What do you need to know about the peak? And this is only looking at voltage. And what was that answer? I'm sorry? No, this is not as much as how long. I'm talking about the peak, not about how long it stays open. If you measured from here to here, called pulse width, or milliseconds of time, then you would be correct. But I'm talking about the peak voltage, this high peak here. We need to know something about that. How many guys check this? That's why you got curses on your scope. And we're not talking about, shit and bitch type of curses. We're talking about voltage and time measurement curses. Okay? So what do you think? Does anyone know what you look for there? Okay. You want to look for voltage here. What's the peak voltage, minimum peak voltage? 35 volts is a minimum. If you don't see 35 volts, you have a problem. Remember, a fuel injector is nothing more than a little steel bar with windings around it, similar to an ignition coil, right? It's going to take those 12 or 15 volts and boost it up somewhat, especially when you disconnect. Doesn't a coil do that every time it's firing a spark plug? Same thing there. That's the end of the cycle when you pull it off. So 35 volts. Does this tell us if I had 35 plus volts, I got good voltage coming in, I have good ground, does that mean the injector is good? Electrically, mechanically, whatever.
You're feeling pretty good,
yeah. Electrically, you're doing pretty good. Right. How about, is this thing really working? You don't know. Okay. Now, I don't know if some of you guys read the article I wrote for Motor Age, I think it was last month. Got a comment from a guy on IATN, and I don't usually respond to them, But a friend of mine, Miles Wada, and if you guys, by the way, use a Modus, you'd like to go to the Snap-on user group on IATN, Miles happens to be one sharp guy, takes pictures and case studies. The guy's a genius, okay? And when I was out in California 2 weeks ago, I did meet with him, and he was kind enough to email me and said, hey, G, I had the same exact problem on a Chrysler vehicle, and I actually emailed this guy. I hope you don't mind, but I posted it on IATN, you know, in your defense, that the little problem that everyone looks at, or the little thing we look at, as voltage goes down, amperage goes up. As voltage drop, amperage goes down. And then we have something called that little pintle hump, okay? Or gull wing, or whatever people want to call it. Some people are very locked in and anal. And what I mean by locked in and anal is that they think that everything has to be 50 or 60% somewhere in that ball game. Of course, they heard that in a class they were in. If it's not 50 or 60% of it, you got a problem. Well, the vehicle I wrote about was a student of mine that brought it into the training center. And make a long story short, on this Jeep with the multi-tip injector, not the regular pintle that's going in and out, the multi-tip type one. He had a 303 and 305 code. He changed the coils, he swapped stuff around, he put in new plugs, he put a new fuel pump in the car. He still had the same problem. When he brought it in, he did this. He looked at all of the voltage. Okay, you guys said electrically, that's good. I'm getting voltage, it's peaking up. He didn't look at the amperage. And as you know, on the new cars, it's not that easy to get around the wires. We had to get a little razor blade because you know, never go around the plastic shielding. Your amp clamp won't work in most cases. You know to zero your amp clamp first, correct? You know you better have a good battery in the amp clamp. If not, you're going to run into all these problems. You know the brake laid little pieces of metal particles better not be on the jaws, and the jaws must be totally closed. I mean, I constantly see guys, it's opened a little bit, and they think that's okay. They got to be closed. Well, when we did all of that, what did I do? I want to know the cylinders that have the problem. I got to look at them, right? The other ones that didn't have the problem, I go over to a few of them, I take a reading. Using the scope that I used, I captured that one on a Fluke, I took that and I put it in memory. The reason why I did that is I play a matchup game. I took that and went to other good ones, and if all of them looked like this, soon as I got over to the bad one, it looked like that. It's not rocket science. It's either the 4 up or the 1. Said, hey, this is bad. Never mind where this wing was at, whether it was up here or down there, who cares? I knew I had a problem with those. Why? It didn't look the same. So Miles Wada did this whole nice thing. He apparently got this off Motorage. He took the little things that I submitted, put them in there. He overlaid it on a Modus screen on the same ones he had, and then the guy, of course, kept his mouth shut. He made one comment that said, I hope Ragsdale takes a look at it, or I want to see what Ragsdale wants to say. Well, Ragsdale never answered back, okay, because a lot of people do respect Miles Wada out there and Danny Owama, two good guys that really know their stuff. So at any rate, you need to see amperage. What is a good amperage reading to have? What's a good amperage reading?
3 amps.
This is a saturated drive injector. How much amperage would you say this thing is good or bad at?
1 amp.
How much?
1.
Good. Approximately 900 milliamps to about 1.2 amps. Most of them hover, like he said, about 1 amp, somewhere in that range, with fuel going through them. Of course, if the little screen is all clogged up with debris, that's going to lower the amperage reading, correct? Okay. So now that you know that, you want to look on a saturated drive for somewhere in this range. If it's lower, you may have a delivery problem or a poor connection problem. If it's higher, you got a problem. This number right here, 1.2 amps, this is a very important number to know. If anything exceeds that in the computer circuit for more than about 6 milliseconds, do you know what you have now? You got a fried computer. It just burnt that driver out. There's absolutely nothing on any vehicle computer, with the exception we go into diesels, that actually pulls more than 1.2 amps for 6 milliseconds. Nothing. Now, I know some of you guys are probably going, hold it. We got that other type of injector called what, gentlemen? We'll talk about these a little later on, too. Good. Peak and hold. So when you got peak and hold, some peak and holds, some peak and hold injectors, they go down and they go up. They go up here, they pull approximately 4 to 6 amps, depending on the manufacturer, whether General Motors or Bosch. They come down, and right here, this is called the hold. Guess what they hold at before they go down to 0 amps? 900 milliamps to 1.2 amps. This amperage right here that I just told you can't go over 1.2, how do they do that? It's done very quickly, isn't it? Why? Because they got to get fuel inside the cylinder. Does that make sense? If we had a battery and I took a wire and there's no hydrogen gas to blow my butt up, and I did this real quick, I'm not going to burn the wire up, but I'm going to get that wire hot. And if I put a component across that, I'm going to open that thing up real quick. Does that make sense? Any questions on that? So you know you got to look for amperage. Amperage is the thing that does work. I always like relating it to the starter motor. The starter motor, you got 12 volts going down to it. You just ohm checked it out of the box before you put it in. You got a good ohm resistance reading on the motor. There was no OL, no open. You had some resistance. You throw it in the car. Does that mean it's going to work? You got a new battery, good cable, no voltage drop in it. Does that mean that's going to work? No. Only amperage does work. Same thing when we're talking about any type of solenoid. This happens to be a fuel injector. Everyone okay with that? Okay.
Less because the injector doesn't have to fight against the pressure of the fuel pulled up, so it just doesn't need the current.
That is correct. So mechanical resistance, and here's another way to think about it. When it's 0 degrees out and someone put 40 weight oil in your car, that starter motor is going to pull more amps, isn't it? Why? The oil's thick. Now we take that same car, put 5 weight oil, 520, 530, whatever, and we make it 70 degrees out. Same car. It's going to be less amperage, isn't it? If we took all the spark plugs out of the car, what happens to amperage? Really drops. That's all mechanical resistance. That can make electrical current go up. Does that make sense, everyone? Okay. Any other questions or comments? Okay, so let's move along. You can see here if you were counting up, as we told you on a scope. And one of the things I forgot to say, for you guys that don't use a scope, everyone in here, and I had a couple of guys the past few nights that said, hey, I never used the scope. I don't know if there's anyone in here that never used the scope. Is there? Okay, good. You could use a test light, I bet, right? If you can use a test light, you can use a meter, you can use a scope. It's the same way of hooking it up. The difference is interpreting the reading. The frustration of setting up, we'll talk about that in a couple of minutes as we continue to go through. Excuse me. So you can see you got 2 volts for a box. We counted up. If we counted it up on 8 boxes, we have 16 volts. You can see if we count across in 10 milliseconds, we would have 100 milliseconds of time. Okay. So again, if you have a Modus or a EScope or whatever, know that it's per screen. Only difference. This operates. Now, if you're looking at a signal, let's take a square wave. And there's all different square waves. Some are 5 volts. Some may be 6. Some may be 7, 8, 9, 10, or 12, depending on the manufacturer. Why? Who knows? Some manufacturer wanted to do that. It doesn't really matter, does it? What you need to know is a couple of things here. If I didn't have a scope and I looked at this very signal that's 6 volts up top, what would my meter read? On average, at half the volts, 3 volts. So there's one thing that gets you in the pants, right? You'd be better off with a logic probe. For you guys not familiar with a logic probe, green means it's ground, yellow meant it's switched, and red meant it was high voltage. You would see at least that it was switching. The meter only averages it. Is the meter going to tell you if you had a rounded curve or something was dropping out on top or on the bottom? No. Only a signature test is going to show you if you obtain the proper voltage, if the wave is really square, or if it really went all the way down to the bottom. The meter's not going to do that for you, right? So you can see the benefit of using a scope. Now, I got a question for you. If I was on a GM mass airflow sensor, Hitachi style, what do you notice about those? Is that the same as, let's say, a Ford or a Bosch? No. No. What's different with their signature? They have a rounded type signature, don't they? And I'm a lousy artist. Comes up, and it's rounded here on purpose. If it's not rounded, you have a problem. Okay? So there's certain things that you need to know. Some of you guys, as we'll talk about, if you have the Modus, you should own a CF card, a compact flash card for up top, because you could save everything on it and then go back and say, hey, I got my own library of stuff. Okay? Some of you other guys that have different brand scopes, some you could save on your laptop if it's a laptop version. Some you could get the AES Wave, like I've used for years, and then I take just about everyone's scope pad and I throw it in there and I can pop it up. Each scope, gentlemen, will draw a little differently. Okay? Even is like we have the Fluke 97, the 98, the 192, the 196. The 190s are real close. They draw just about the same. The 90, when you compare the 97, the 98, and the 190s, they're different. Every scope is different, never mind different manufacturer. That was an example of the same manufacturer. Does that make sense? So you got to be careful. You got to know your scope, save your form, and then you'll be okay. Trigger. We're not talking about Roy Rogers' horse here when we say trigger. Remember one thing with trigger. Half of the voltage is where you should set it at. So if I'm working on that fuel injector, we said maybe 14 volts, my trigger should be at 7. I got a 5-volt cam sensor, I'm going to be at 2.5 volts. I got an 8-volt crank sensor, I'm going to be at 4 volts. Why? It'll give you this most steadiest pattern possible. So trigger at half of it, it'll give you some sort of a picture on your scope. Some of you guys got auto, but we're going to talk about auto, how it's going to screw you. If there was a standard transmission car outside and we had to get someone to the hospital, and you only knew how to drive an automatic in here, we'd be up the creek without a paddle. Okay? You have to know how to set stuff up. One channel, that's okay. One channel is, one quick check of something. It's multiple channels is really where you're going to start looking, comparing, finding problems. Do you guys remember the article that I wrote a while back on that Jeep? Okay, and we'll talk a little deeper about the cam and crank sync a little later on. Well, on some of the scopes that we put that on, you could not really tell the correlation between the cam and the crank, because some scopes, you can't move everything the way it's hanging off a little bit. You want to line stuff up, it gets a little tough. So some scopes have a little more power. If I didn't have the scope at that point to utilize to line things up, I may miss the problem. So that becomes a problem for all of us, right? We need to know how to line stuff up, when to use it, and when to use the right trigger. We'll all take trigger off. How many of you guys have a car, you drive down the road and it cuts out, you don't know if it's fuel or spark, right? Well, we talked about signature here is this brown waveform, and we're going to talk about signature. So let's talk about this fuel injection signature first, because that's my fuel, and let's talk about primary ignition signature. Once you see a signature, I got the good voltage, I got the ground, I have the peak, it looks like it's a fuel injector, it looks like it's primary ignition. Do you really care about that once you looked at it? What are you going to do, stare at it for 20 minutes driving down the road? Your eyes are not going to see it. Isn't this just like staring at the meter? But min-max catches it, but your eyeballs swear that that thing never went out of the voltage range. But the little bar on the bottom is doing this. You just can't pick it up. So what I like you to do is, if you're a sharp tech on any scope, by the way, this is a generic thing, anyone's scope. If you were doing this at 2 milliseconds per division or 20 milliseconds per screen, okay, you're going to take it and tighten it up. You're going to make this look like all these little doohickeys. You're going to make this look like all these little doohickeys. Now, why are you going to do that? Because you want to see if something dropped out, right? Now, you got a choice. You got one trigger set up on your scope, right? If I had the choice of going to ignition or fuel, where am I going to put my trigger on? Where would you want to do this to diagnose this cutout problem? I'm going to go right to ignition. Why? Without ignition, I'm probably not going to have spark 9 out of 10 of the cars. So watch this. If my ignition keeps going, but my fuel cut out with a high line, it never went back to ground, I would see that problem, wouldn't I? You know why? Because I'm triggering off ignition. If they both die exactly at the same time, I'm going to have to check that ignition circuit a little better. So that's one way to use trigger to figure out where do I go, spark or fuel. Does that make sense? Has anyone ever used that? Okay. We used to capture a lot of these.
Where would you tie into that? Where would you tie into
Primary ignition, I don't care if you go to the negative side of the coil. Simple. And when you got coil on plugs, then you just go to one of them. You can go to the PCM, right? You know, one of the things that I used to see John did, he'd really work hard on secondary ignition. You know, I don't work hard on secondary ignition. I'll go to primary because secondary is going to mimic primary pretty closely. Enough for what I need to know about this car. When we got to hook all these little adapters on it, all this, dude, that's too much time. That's too many wires for me. I don't have time for all those wires and connectors. I want to see what's happening right now, and boom. And you can do this with as simple as a 2-channel scope. Okay. Any other questions? So go to primary, go to the fuel, and this could be any type of fuel control. You can do it with anything, by the way. You know, we could go to any solenoid to see what's going on. We could relate this to anything, you know, on sensing and comparing something. If you think the crank or cam fell out, if you're doing cam and crank, one's cutting out. I'm going to go to crank first. Why? That's more signals. It's going around 2 to 1, right? Going to go there. I'm going to trigger off that. Nowhere to trigger. Trigger at half the voltage. Everyone all right? Okay, let's move on. Okay, now we got the Modus. The little thumb pad up there. The Modus is a nice 4-channel scope. By the way, if you have the latest version, 6.4, you should have a sticker. If you've been updated, your dealer is supposed to put a sticker on. And this is what Snap-on asked me to pass along, so it's exactly what I'm doing. So if you get an update, you should have the 6.4 sticker. Somewhere there, your dealer has a roll of them. You should also know if you buy a new unit, you got a better screen and a better processor. So the screen is a bit brighter, the processor is a bit faster, and it's a pretty nice unit. You got 4 different colors. And again, I apologize for some of the pictures and stuff. Having been on the road a while, when I put this together, took a little consensus of what people had. Modus came in number 1, followed by a lot of people that either bought Genesis or had it, and followed by Fluke and so on. So those were the scopes I covered in that order. Now, one of the things you got to know, and I want you to write this down, all you dudes that have Modus. What do you notice here on the screen? We're going to have to do a little blow-up doll here. So bear with me. What do you notice on that yellow channel going on? We got some voltage going on here, gentlemen. What do you notice about our battery? It's green. What's that mean?
Good.
It's good because I'm plugged in. When you're doing any diagnosis, gentlemen, on anyone's scope, but this is an example on this scope. When you're trying to diagnose something, make sure your battery is already fresh, meaning charged up. When I plug this in, I am not connected to anything here. If I slow my time up, it will look like this, gentlemen, like I got AC voltage coming out of a crank sensor. How about working on a vehicle? You want a battery charger on the battery when you're testing the system? No. You don't even want a scan tool plugged in, anyone's scan tool, plugged in the diagnostic link connector when you start doing pinouts. Why? It could change your reading. You want to be aware of that. If it doesn't, that's good. If it does, I've been bit over the years like that. But this is a real problem, okay, that you can encounter because a lot of guys have battery problems. And what do? They plug it in, only when they're going to use it. This is not bad if we're using it for the scan part of it, but we're dealing with a scope part, I'm pulling noise in there. That's not good, okay? So make sure your battery is full. Okay, we'll play the little thing. Now, you're going to feel a little queasy, but you'll have to pay attention. You can see the line of voltage going across the screen. It's going up and down. I'm hooked up to Bernie's board, running it. When I did this without the battery thing plugged in, you can see up top, without it plugged in, I didn't have a problem. I had no voltage on that. How many guys have taken their digital voltometer, and I want you to do this tomorrow, take your digital voltometer, put the wires in the red voltage port and the common port. Put it on AC volts and just do this, just like this. I'm not talking about going like this. Just do this, and you know what you're going to see? You're going to pick up the AC voltage that's around. Your leads are antennas. So you need to be careful. You guys that got those metal lights that'll burn your arm off, you got to keep that away from your scope when you're using it. Everyone okay with that? Question?
If you're hooked up to the battery itself, environment, you're going to find that way?
It is a lot better. You may still encounter some sort of problem, but most likely not as bad. And what he asked, for in case you guys couldn't hear it in the back, if I'm hooked up with the connector to the battery of the vehicle. I'd rather you go to a power pack, by the way, because you're running the car. AC always rides on DC. You got AC voltage coming in. I don't like going to the battery. I like going to some other ground that it's already buffed. But that's just, check it out. You know what it is? Each scope's going to be a little different. The lower the voltage you go, the more noise you pick up. Does everyone understand that? You want to do an oxygen sensor at 200 millivolts per division, your voltage is going to be low. What's going to happen? You're going to pick up more noise. Okay? So that kind of confuses people. We'll talk about the lead right here. Some of you guys had a problem, and this is my tech rep guy, Bruce, good guy, over in the New York, Connecticut area. And Bruce asked me to make sure that everyone knows when you connect these, you don't plug them up and piggyback them, because a lot of guys have been breaking them. You just plug one in, and then you can go off the end to piggyback as many as you want. The other thing I want you to be aware of, these leads are not Cat 3 certified. The end of the lead is, meaning the clip, but that doesn't mean the lead itself is. You cannot use this on, again, a high voltage vehicle, meaning a hybrid. You could use the scope part of it, but you cannot, the scan tool part, excuse me, you cannot use the scope part.
But the meter itself isn't Cat 3 either. It's not just...
If it's not rated up top, if you don't see it rated up top, you can't use it. I know the leads for definitely are not 100% sure, not certified. Okay, so be very careful if you're going to use that. Snap-on does have a meter. The Blue Point meter, they do make a couple of them. The high-end ones are certified. Okay, you can use that. So be careful with the little connector ends. Come on, clicker. Okay, we're going to go through some of these screens here. If you go into utilities, if you're like me, you probably got aggravated at one point with the thumb pad, right? You know, one of the things about some multiple type of tool that does multiple things, buttonology sometimes is a little tricky. They're trying to make the pad, you know, up or down, right or left. Sometimes, as you've all encountered, I'm sure, up was down, down was up, right? Gets you a little aggravated, and they have fixed quite a bit of that. Also, sometimes the double clicks that you have to do. If you go into utilities and you click Easy Scroll will help you get through a little easier. It'll pop stuff up when you have a box highlighted in scope. Does anyone use that? Okay, seems to work pretty good. The other thing I want you to be aware of, if you go over a little more into tool setups, you can go into power management, printer, date, time, and your brightness and contrast of the screen. Okay, so we'll walk you through the unit. You could also save stuff to the top of the unit. All these screens I saved right to my compact flash. Okay, so compact flashes are very, very cheap. This is the big card, about yay big. Newer laptops like this don't even accept them. You got to use a little adapter to put in there so you can go to the bigger one. You buy these things for practically nothing. You can put it on top of it. You save everything as a bitmap. You save it as a bitmap. It doesn't matter if I gave this to anyone. I could put this on the internet. Okay? I can give this to anyone that has a computer. They'd be able to view these screens. Does that make sense? And isn't this nice to give out once it's on your computer to print it out for your customer? Not these shots, obviously, but I'm talking about a Labscope shot, the before and after of the job. I used to do this with my old MT2500, my old Tektronix and Fluke Labscope. I used to print everything out to a dot matrix printer. One copy for me, one for the customer. And I'm going back to the old dot matrix that had that old printer connection. I think it was called Centronic. It would have a female where you had to put the male plug in. It was weird looking, the printer. And I bought this box from a company called Black Box. Black Box is for computer companies. They use all this special gizmo. And I plugged in my DB25 or my DB9. I had all these converters. but I printed everything out. So when a customer walked away with a bill that was, $400 or $500, they didn't go, the hell did that guy do for $400 or $500? Oh, they knew what I did. I did a whole bunch of stuff, and even something I just came across cleaning the training center up. I had my old Polaroid camera before digital cameras. I used to take Polaroid pictures. Seeing is believing, okay? So that's some of the stuff you can do, saving it. You could also, you could save stuff, load a setup that you had in there. Pretty nice. If you have something there, load it right up. Boom. You can view it. You can use the settings, okay? Some of you guys don't use this. The nice thing here is once you get across, when a box is highlighted like this in blue, we would need to use this thumb wheel to go across and come down. Once you come down, as you could see, I'm in yellow, meaning anything I set here is going to be for the yellow setup. I have already moved my lines to where I want them, okay? I've already set up 5 volts. That means the whole screen is going to be 5 volts. Up here is going to be per division, meaning these little lines as I go past, if you add them up, all the big fat ones there are going to be, if I start at the bottom, 500, 1 volt, 1.5 volts, 2 volts, till I get to 5 volts. Does that make sense? That's how we're going to count up. Same with the time going across, if that was 2, 4, 6, 8, 10, or it would be 1 millisecond actually because it's 10 total. So 1, 2, 3, and so on. Everyone okay with that? Now, a lot of guys that come into hands-on classes when I do scopes, I see this as a major problem. They don't know how to put the lines on. They don't know how to put the lines off. This is why I'm covering some of this. Because you can't get the most out of your lab scope if you don't know how to use it. You spent $8,000 or $2,000, whatever you spent for the product, it doesn't matter. You better know how to use it. You got to spend the time to learn and the money to learn how to use it. So we'll talk about going through. When we click on this box, we could come up with channel 1, 2, 3, or 4. In this case, I have channel 1 selected, and I'm going to click the display. Display is going to tell me that the line is going to be there. Okay, you'll see in a couple of screens later it won't be there. You could invert something. Why am I going to use invert? Oh, you've all done this like me, right? You break your noodles trying to get this amp clamp on something, right? And then it's upside down. You got 2 things you can do. You could either do the software invert or just switch the leads around. Whatever floats your boat, okay? Just make sure you zeroed it beforehand, okay? So that comes in. You could also couple it to AC, meaning rather than DC, you're AC coupled. Peak detection to see the peak voltage. Filter to filter something out. And auto find, which is really nice. You're not sure about something, hit auto find. It goes through and does a search on that channel. That way you get some sort of reading. This on other scopes is called like free run, okay? Or on Bernie's scope, he calls that roll mode or something or another, okay? So it just finds something going through. And here I'm just going through some of these different screens, as you can see. I just took off the red line, didn't I? So when I went to channel 4, you notice I have the display unclicked. I lose the line up top. It tells me it's off. The earlier software didn't have that, but the new software does have it. I'm talking very early software. And that's kind of nice that you could see everything up top. Kind of nice setup. So you can put it on and off. You can see as I'm going through. When you get into this section here, low amp clamp, 20 and 40, the PSI, ignition probe, or test leads. Now, this does not mean that you cannot use a generic PDI clamp or some other brand clamp and put it on the scope. It's what I see a lot of students come in, they think they got to buy the Snap-on brand, or if it's on OTC, they think they got to buy the OTC brand. An amp clamp is an amp clamp. You put it on there, and I'd much rather you go to every 100 millivolts equals 1 amp and set it up on voltage. Because a lab scope, gentlemen, does not read amperage. Does not read resistance, it only reads voltage. It's a conversion from volts to amps. Is everyone clear with that? So if you set it up that every 100 millivolts equals 1 amp, guess what? You're going to get the best resolution. It's going to give you a nice clean picture. These things are for someone that you're not 100% sure. And that's what's nice about this unit. Just like Troubleshooter in the scan tool version. It helps you out, just like something else we'll get to in here, all the presets. It helps you out when you got a brain fart. We all have brain farts once in a while, don't we? That's where these things come in handy. You go over to the voltage. You can do from 100 millivolts for the whole screen to 400 volts for the whole screen. Well, a lot of hybrids exceed 500 volts. Another reason why, even if you had it, you had the leads, the unit itself can't do it. And again, do not plug into it. You could be dealing with something that's super dangerous. Okay. We had, just a quick thing to tell you, we were running 2 500-watt bulbs off a Honda hybrid, and I told the guy not to race it up, but when you're teaching people that work for a union, they don't care. I probably shouldn't have mentioned don't race it up. The guy probably wouldn't have raced it up. So what does he do? He races it up, and we're running off the AC voltage on this vehicle, the same stuff your meter would be, exposed to. It vaporized the bulbs, gentlemen. Vaporized them. There wasn't a piece of glass left. They were gone. Okay? So just think if your meter exploded. Fluke on their website has a meter that's out of Korea that says it's certified, has all the stuff on it that you'd believe. They put it on there, they show you, and it blows up. You got to be careful what you buy. So please be aware of all of those things. Here's that AC voltage again, in case you missed it. What would happen if I tightened the time up again? It would look like an AC signal going above and below. You may think your crank sense is good and you're not even in the hole. How many times we've done that, right? I'll tell you a quick story. When I first bought, the first scope I ever bought was a Fluke 97. And they had this little test they came out with. You mail it in, yada, yada, yada. I mail it in, I get 100 on them. I'm real good on their board, boy. I can do anything on that little board they gave me. I go to hook to some of the cars, and I could not get this damn thing to work. Now, back then, they didn't have the T-pins, or at least I didn't know about them. They probably had them, but they weren't being used. The T-pin is a little T, goes down, and that's what I use for back probing. They gave you these little round things, looks like an old hat pin or something, and it really didn't go in the weather packing real good. And one of the things I didn't realize at first is I can't get these signals to come up on a scope. I had just spent over $3,500+ times 5, by the way, because we had them for all the shops. And I was sitting on a lot of money. Okay, and at that point I told the XO lady, I ain't coming home tonight. I got to figure out how to use this because I got to show everyone else how to use it. I could do it in the book, couldn't do it on a car. One of the first things you'll want to look at is if you have any voltage. So I started going to the meter section of it. I noticed I had no voltage. A lot of times it was just a bad connection. Once I realized that, I took a paper clip and I put it on the grinder, okay, and I sharpened the stuff up, I stuck it in there. Now I was getting a whole bunch of stuff. I was amazed. I was using this thing like I did on the board. A lot of times it's where you stick it, okay? And we'll talk about that. Some guys are intimidated where to stick it, okay? And some of you dirty mind guys, where you stick it tonight's your business, okay? But that's a whole other ball game. But sticking it sometimes is a problem. It really is. You can't get through. How many times I've been on an oxygen sensor where I know I'm in the hole. I'll take an ohm meter, pull it off, and go from one end here to there. I got a reading. I plug it back in, I still get no reading. Okay? Don't know why. You got to wiggle, jerk, feel, and massage it. It starts working sooner or later. So please be aware that could be quite aggravating. Now, here's what we have set up. This is a 4-channel scope. I have right here, I'm triggered off the fuel injector. The green is ignition. Okay? The red is the O2 sensor. The blue is a TPS sensor. Now, this is something you should be looking at because every computer system on the car, whether it be ABS, air conditioning, or any other system, is always going to deal with what I'm going to say next. And that is, it's going to deal with sense, compare, and adjust. A sensor sees some information, sends it to the computer by voltage. The computer takes that and makes an adjustment, right? So you're going to want to see if that TPS, the blue line, goes up, what's going to happen with this yellow baby? What's going to happen with the fuel injector? It better go that way. We should see ignition starting to pull in more events. Okay? We should see that oxygen sensor line go up, shouldn't we? Okay? So this is what we're going to look for. The next nice thing about this is some of you guys work outside. One of my pet peeves with the Fluke unit, even though the new Fluke is not made for the automotive industry. It's made for the electronic industry. Well, when I did the state of Alaska where hundreds of guys got scopes, you know, during the summer, we worked outside, and if you're familiar with Alaska, you could have 24 hours sunlight in June and July. And we're outside working because it's nice out there, and it's a real pain in the neck to see the screen. The old Fluke 98, I can invert the screen, just like you can do here for outside or bright areas. Unfortunately, they didn't do that. The engineer said, what do you need that for? Because the engineer built it for indoor use. Supposedly, they're going to change that down the road, but they haven't. So here, Snap-on has that built in. In my opinion, that's a very big plus because I know, hey, how many times I worked outside? You know, the bays are full, I got to be outside. Or maybe you're John Anello, you got to be outside. You need to see what the screen is saying to you. Okay. Now we have all the setup here that we talked about: voltage per division, voltage per screen, time per division, the whole time per screen. Just a breakdown of what we were talking about before. Okay, just a breakdown of it. So that's in your handout. Now, what did I do here? What's going on? I raced the idle up, didn't I? How do I know that? Remember the blue line? Where's the blue line? Where's the blue line now? You want to check this out. Let's say you were working on some car you didn't have a scan tool for. You think it's a bad computer. You want to check out if the computer, if anyone's home in it, right? When you step on that TPS, you better see some fuel movement. That fuel injector don't move. That signal is not getting from the sensor to the computer. Or the computer is not commanding it out. You have to find out which way it's going. You could see the ignition events, and I don't know why it changed color. That's just the way it came out in the recording. But the green, you could see a lot more events. You could see another fuel injector coming in. It's almost like, couldn't I get the same effect if I changed my time? If I made that 100 milliseconds, 200 milliseconds, what am I doing? Squeezing it in. When would I use that? Looking for a drop out of problem. Yes, John?
That's what the way the Modus is designed. If the voltage goes over a certain height, it'll change onto white. Just the way it is.
Good tip. Okay. If it goes over a certain voltage, see how it peaked up? Didn't even think of that. Goes to white. Okay. Never noticed that, didn't know that. Thank you, John. That's good. Now we just went right back to idle. Okay, so from racing it up, right back to idle. You should see an effect. Taking some of the lines off again, if you want to pull one out, maybe you don't want to look at the oxygen sensor anymore. You've seen it move. Time to take it out. Maybe you don't want the TPS, you just want ignition, and you just want the fuel injector. It's still all connected, you're still there. You could take this out. Why would I do that? Maybe I seen that those other things were working good. I don't want to look at that. I want to look at these two things, so you can take them in or out. And by the way, if you just go back, you didn't lose anything, just put it right back on. Everyone okay with that? Okay. And we'll just move it back. Now just putting them on, as you can see, just real quick. Move to the next one. Come on, clicker. Okay, let's look at this movie real quick. So you'll get a little dizzy again, didn't have time to edit it. But you can see right now I'm at idle. And by the way, you see the oxygen sensor, the red line in the background going up and down. If you stare at the fuel injector, all good scopes, you'll see this. You'll see some waving on the fuel injector as the oxygen sensor is going up and down. Why? That's what it better do. That's what it's designed to do. The oxygen sensor goes above and below zero. Now we're racing it up. You've seen it being pulled in. You see the injector going wider. It was all the way back there. You see the TPS coming down? The blue came down. We went right back to idle. The red line going up and down. Okay? And again, when that goes up and down, low is lean. When it's lean, the injector should move out somewhat. When it's rich, the injector should move in somewhat. Does that make sense? How many guys have actually tried this? Okay? You know, one of the things, I don't know if you guys went to around here, but First and Edge, or something we ran over in New York State for a while, the ATTP training classes. And years back, a company called Aspire, now Delphi Aspire, they had all of these classes that people had to take in certain states. And when you went through some of these classes, you put a lot of training hours in. You got to understand that your scan tool could be the biggest lying tool. How do you know the scan tool is really telling you the truth? You could have a map sensor that you could graph out on your scan tool, looks perfect. Is that really what's going on? You don't know unless you put a meter or a scope there. You could have a substituted value. An article that Anello wrote years back on ABS. He graphed ABS out on his scan tool. Everything looked hunky-dory. The Labscope showed his problem. Okay? So you got to be careful with scan tools. Okay? And it doesn't matter whose brand. We're talking just generically any brand. Scan tool can only do so much. It takes what's ever given to it, at least out in the output, by what the computer sees as a substituted value. It wants the car to run, right? Ain't going to run if we don't have a map. So now here's another neat feature about this. Going into info, component test, US or imports, come down, ID a vehicle, go through, we'll take a General Motors. We picked a 2003 vehicle, an Impala, and we did a 3.4. Okay, pretty simple. Component test, you're down here. I go into the component test. I'm going to pick a fuel injector. But there's a whole list of stuff. Maybe you don't know how to do crank or cam or sync or evap or fuel pressure. There's a lot of stuff there. Serial data. This is super important for most guys because if you're not good using a scope, maybe you only pick this up once a month. This is a nice plus to have a tool that'll do this.
Hey, Jerry.
Yes?
Excuse me. How do their presets stack up against everybody else's
Most of the time I'd say they work.
as compared to a certain few others?
We'll get into that certain company next. Good question. Most of the time they will work. I mean, I have come across a few problems, but
Close.
they get you close. And the nice thing is it gives you a whole bunch of information, operation, injector control, you know, what you're going to test for. The bottom line is, gentlemen, a lot of times when I'm doing a class, a guy will say, hey, I'm going to look that up in my Modus or in my Genesis because it has all the connection points. I just take the back probe pin, and I don't care if it's a 6-wire sensor. Let's take a mass air sensor, right? I know if it has that many wires, you're going to have a ground for the sensor itself, a ground for probably intake air temperature sensor, a 5-volt reference for that air intake sensor that's going to probably be lower now because it's not minus 40 out. We're going to have another power wire going in, and we're going to have a signal wire, and maybe another ground or something. It's not rocket science. You put it there, as you're doing this, you raise the motor up, the line better move. If you want the line to sweep, what are you going to do? Slow the time up, right? Add more time. If it was 10 milliseconds, you're going to make it 200 milliseconds. It's pretty easy once you understand it, okay? Once you understand it. So here, for guys that don't know that, it's nice they have it in there. And here's how it comes up. You see, we want over voltage there as well, I guess. Notice on this injector, this one tells me where the voltage is. Remember we said earlier on, we know we got a little more than battery voltage, which is good. We pull to ground here. You notice as we start coming up to ground, it's really only at that particular point that they make it go fully down to ground, then they let off it a little bit. That's in the design of the circuitry. Because if you leave something down all the way to ground all the time, we could have a problem, right? How about if you had a system, a car you hook up to, and you have a line like this, goes to ground, and goes all the way across your scope. You don't see this peak, but it's down all the way. What type of problem do you have? The wire going to it is shorted to ground, isn't it? It's keeping it on all the time. How can you check this? You could take the connector, take it out of the fuel injector, run a jumper wire from there to the computer, and now if you see this injector pulsing normally, that wire is shorted from somewhere from the PCM to the component. That's a way for you to test something. Down and dirty. Now, you should fix or replace the wire and put everything back to normal. Because it shouldn't be all the way down to ground. If you had a straight line of voltage that just kept going, you know that driver ain't pulling it down to ground. What can you do to test it? Well, you could take that negative wire that's coming to the computer, if you think it's a ground wire, or maybe the wire's open between me and you. So what do? I take a little ground wire, and if I go like this, and I have my scope outside, I better see that thing go down. If it does that, what does it confirm? I got a computer problem. Does that make sense? This stuff, again, is not all that hard. Some people make it out to be rocket science. It's not. You got to think of basics. Okay, you know, I always tell people, if you see the roof is sagging, don't jump for the roof. What you really want to go for is the foundation to see why that is sagging. Because a lot of people just throw it at the roof. You're going to run into a problem if you do that. Okay? Most problems are really not that hard. So a nice setup there. It gives you the whole pooper scooper. You could do AC volts. And by the way, I didn't even have to couple it for AC. It'll do it, which is kind of nice. You could go in there and couple it if you'd like, but it'll pick it up. That's a crank sensor. There is a square wave. Nice and easy. And just to show you this little clip too before we move on. You have it all set up. You look at all your setup on the screen. You're going to see this thing pop up pretty much instantly when I start it up. You're all done. So if you had a brain fart, but again, this is limited. This is limited. I always say, you know, guys that use something like one channel, you got 4 channels to use. You want to compare stuff. You know, how about putting 4 injectors on there and seeing what's going on so you can do a comparison? How about looking at something else like the sensor? Is something making that injector stay wider than, let's say, 3 or 4 milliseconds? Why is it wider? Okay? You got to compare. John?
Also, tagging every crank and cam sensor you can on different engines and saving in the database for crank cam correlation.
Very good. Or one of our guest speakers coming out, John Thompson. He sells that book or CD. I think he was out here about a year ago. Okay? He sells that nice book that you can look in that gives you the cam and crank so you can see how they're set up. Bernie on his scope has it built in there. So depending on what you have, you really like to go take a look and see what's out there. Here's the second most popular one out there. And again, both Modus and Genesis have what I call system machines. For Modus, it's the Vantage Pro. For the Genesis, it's the Celerity, correct? Did I get that right? Okay. A lot of good information in this unit, but we'll talk about some of the pitfalls. You go right into Labscope. You could set the channel up. Now here's where you got to be Houdini. This is my opinion. Up is down, down is up, right is left, left is right, and only some of the times. Plus you got to hit these soft keys. So you can see you could go through, you could put 1 channel or 4 channels on. You can make any color you want. The leads, by the way, are dangerous. Cannot be used on a hybrid. Metal B and C ends. B and C connector is the twist top with little tits in them. Cannot use this on a hybrid vehicle. It's not certified, and the leads are far from being nice leads. The ends of these leads are very heavy also. And what I mean by that is anyone that has this scope, they got this big metal jaw that comes out. If I'm using multiple channels and I'm pinning at a computer, and I got my T-pins in there, you know Murphy's Law, I race the engine up, so you're going to short something out. So if I use them, it's duct tape or something in between them because I don't want this puppy to fall out. Question back there, or you're just waving hello to me? Hi to you too. It's okay. Okay. So you walk through, you just put on whatever channel you want. You can see there's more channels coming on. Sometimes my finger's over there, sometimes it's not. Now I'm going up with the finger. I'm not giving you the middle finger. Oh, that is the middle finger, but I'm not giving it to you. I think I'm getting the middle finger with it. That's a whole other ball game. So that wasn't intentional, by the way. Just the finger I happen to use. 4 channel, you got a blue on the bottom, green, yellow, red. One of the things that's a little hard for you to see, we got up top here the time and the voltages going down. I could pick AC or DC. I could move it around to take a voltage like here. If I want to move it, I got to hit enter. The way this scope operates, which is kind of funny, is you notice like the box is white. When I make the box black, okay, that's where I'm going to adjust the voltage or the time or whatever. And it gets a little confusing after a while. Okay. Just so you're aware of it. Usually, like anything, if you play with it, just like the Modus could be tricky. After a while, it's not as bad. Put it this way. These multi-use scopes, in my opinion, these are for the occasional users. If you really want to diagnose a car, you're going to see the other scopes that we're talking about. I would not pull this out, personal opinion. I would not pull this out if I had a real nightmare problem of a vehicle. This is occasional, I want to look at something. Same with the Modus. I want to take a quick peek. It's there. I'm happy. I'm done. Okay? Which most of you guys will probably use. Okay, so we're just going through different lines. I'm setting up. You can see one line there, probably for the O2 sensor. There's the 0. There's the line going up and down. Just moving through screens. Took some of them off right now, or one of them off, actually. So you can go through. You can change the voltage. I made one 25 volts per division, 4 volts, one 1.6 volts. Got 2 of them on AC, 1 on DC. You could play the whole setup game. Ooh. No, okay. Now trigger. Oh, this could drive you crazy. Trigger on this one, you're going to have to get over it by hitting a soft key that would tell you trigger on the bottom. And then you're going to have to put this on or off. Rising or falling edge, meaning you're going to go from high voltage to low or low voltage to high. Not the greatest trigger setup out there. You can move it over a little bit with these lines going back and forth. You can see sometimes where your finger got to be. You would think, well, hold it, I want to go this way. Wouldn't it be cool if I can use the button goes that way? Maybe I'm a moron. I don't know. But sometimes that's the way it is out there. So you can move it along. And by the way, when you want to highlight one of these boxes to change something, let's say you wanted to move that yellow line, I got to hit an enter, move it over, and make sure that box goes black. Now, if you don't know that, you're going to be pressing all these buttons, go, damn it, I can't move that line up and down, I can't set this thing up. You really need to play with buttonology. Okay? Again, it's a multi-purpose tool. So they have buttons sometimes. I guess one engineer makes it do one thing on the scan tool side, and the guy on the other side didn't talk to him. I don't know. So here, just we'll play a little video real quick. You have the fuel injector, ignition, TPS, and oxygen sensor. And you're going to get dizzy. I'm doing one hand. It's 1 o'clock plus in the morning, trying to finish this up for you guys so you can get some views of different scopes. What am I doing there? I'm racing it up. And you're going to see I'm starting to soon to change time. You can see the oxygen sensor there. Now watch as we start getting more of these in. You're going to see a TPS starting to come in. You see the oxygen sensor changing. You can see this one's the TPS sensor now. You see all these little dropouts? Okay, these are all the ignition, all the injectors. So when I tightened my time up, I lost what used to look like ignition, but look at here. Did I see a dropout? Okay. Now, of course, you all are familiar with Bernie's board. On Bernie's board, I put that in. I tightened the time up so the line that was in green that did this, now it started to look like a real TPS switch. The oxygen sensor started to slow up because I took the time and added more time. And when I see a dropout, I didn't see a hole in here, but I seen something happen here on the injector rather than the ignition. Okay? So just like I told you before, you can do this on anyone's scope. Does that make sense? Then we'll tell you a little story as we're moving along. And we'll give you a break in about 5 minutes. Let's start on the Fluke 98. The Fluke 98 scope, very popular scope that was out there, no longer made. A problem with this scope as well as the 2 previous scopes. How many of you guys know what an isolated channel is? Okay. Do you need individual power and ground? Now, this is real important. When you don't have an isolated ground, what could happen to the vehicle you're working on? Few things. You all like to do AC crank sensors, right? Or an ABS wheel speed sensor. Any actuator that goes to the computer, IAC motor, EVAP solenoid, EGR solenoid, ABS controller, okay? Anything that makes anything that's a solenoid, any transmission solenoid, any of those things you go on, if you went to AC voltage, here's what's going to happen if you don't have an isolated ground scope, especially if the ground pops off. First of all, you're all familiar with the lead sets that we have seen come with most of these units. The lead sets come out and they have a little connector that goes off and you have a little alligator clip here and there, right? Most of you guys put this one to where? The ground. The other one goes to the map or whatever. Well, if you do that and you do not have an isolated scope, and this is not an isolated scope, AC voltage will come in the one side that you're testing, and whether it's the IAC motor or any solenoid like I just mentioned, it's going to go out. Where does the IAC motor go to be controlled? To the computer. Soon as you put the AC in, you know what's going to happen? It's going to go right to the computer, can burn the computer right out. You work on some BMWs, they got an AC crank sensor, don't they? Work on the older Jeeps, they had an AC crank sensor. And it's going to shut the vehicle off if you're lucky, and maybe it'll restart, or burn the unit right out. And most people don't know this. Quick other story, years back I'm doing a class, hands-on. I have the Fluke 97, this goes way back. The Fluke 98 was just coming out. The 97, the leads weren't like this. They gave you a ground lead that went in here that you had to always ground, and they gave you just a straight lead and another straight lead. So I had one on the fuel injector, one on the AC crank sensor, the black lead on ground. I have no problem getting good signal. Well, one of the guys was going to buy a Fluke 98, says, hey, put that on there. Put that on, LS2000s, whatever else was around at the time, the Intero unit. Well, as soon as we put that Fluke 98 on that had this type of lead, that Jeep shut right off. Boom, couldn't get it started. Now you're doing a hands-on class. They're looking at me, I'm like, oh boy, it's never happened to me before, okay? So first thing I always think, hey, this thing was just running. I'm just going to disconnect what I just put on it. I disconnected the leads, it starts back up, put them on, boom, shuts off. How could this be? I take the leads off the Fluke 97, I put them on the 98. So that means I take one from the middle, put it on, put the 97 on. It works on the 98. I know it's not the 98 doing it. I take the leads from the 98, put on the 97, boom, shuts it off. Now, I had never heard at that point, this goes quite a few years back, I had never heard of isolated channels or isolated grounds, you know, as far as the scope. I call up George Menchel. Okay, George is the Labscope guru in the country. He didn't know. I call up Corey Glassman from Fluke. He was their automotive guy. He didn't have a clue. I finally speak to a guy that I did some work for, Jack Benton, who used to work for Fluke, and put me in touch with one of the engineers. And he said, I don't know anything about cars, but tell me what you're doing. And I explained to him. He said, oh, AC voltage, and where's that DC voltage going to? I said, well, the computer is supplying ground because you got 12 volts going to it already. He goes, oh, that's just going right in. You could burn the computer up. And you all know our board member, Pierre, right? Pierre tells that nice story when he was at the racetrack with his friend. And he had his Fluke 98, and Pierre already had heard my nightmare, and he put the ground on somewhere in this race car. You know, race cars, you know, guys ready to do a round, and run rather, and Pierre's checking out AC voltage, and he's checking out his injector. The ground wire pops off. The guy never got to run the race. No. He wanted to kill Pierre. Okay. The last 2 nights, Pierre was there, and I let him tell the story. He's like, wow. So you guys that don't know that, whether you're on a Genesis, whether you're on a Modus, whether you're on a Fluke 98 or the old Tektronix units, if it doesn't say isolated ground up top, it has to be stamped. It's like, just like UL or the CAT certification, it's all of that stuff that has to be right on the unit. It's not something you're going to find in fine writing that they'll say, oh, ours does it, it's in the fine writing. It has to be on a unit, okay? The other nice thing I liked about this scope, I helped work on the scope as a consultant after the first 98. This is the Series 2. I did like that you can come down, and anyone that ever comes to my class, I think Al was in my class at one point, I tell you, forget about presets. That's for wussies, okay? Go into scope, and once you're in scope, I like you to go over and go into the 2-channel part of it. But before we go there for a diagnostic problem, you notice what Fluke did here? They have electrical system test. Because watch where I'm going with this. Electrical system test, you had to take the lead out, the red lead, hook it to positive and negative of the battery. When you hooked it to positive and negative of the battery, I could see charging voltage. I coupled the scope to AC from DC. Now what am I looking at, gentlemen? AC ripple. More than 500 millivolts, I got an alternator problem. The third step was I put this little blue filter on. And then I went right over to here. It's called relative compression. Relative compression is very, very important. And you can do this on a Modus, a Vantage, a OTC Genesis, or their sister scope, the Celerity. The thing you want to do is check the mechanical condition. Because if you have a vehicle that comes in with a map sensor code, okay, and you look at, oh, it has a map sensor code, voltage is off, the thing you're going to probably wind up doing is changing the map sensor. Meanwhile, it's the engine vacuum causing the sensor problem. You don't fix a vehicle unless you check the basics. You remember the big box scopes, the Suns, the Allens, the Bears, all of those, the Marquettes? Guess what? They forced you to do that. I used to yell at my guys. They take half the leads and go, throw them in the bottom of the Sun machine. Screw that. You know, we're not going to use that. It's too much work. That's where you're going to miss something. When you go over and you see something, whether it's a square box like this, the Fluke used to have little square boxes, and you got, hey, I know I got one cylinder that has a problem, and I'm too lazy to sync it. I'm not going to pull out extra wires when I don't need to. And what do I mean by syncing? Number one, spark plug wire. Number one, injector. Why? Because I got to know 1342 where it is. When it's not synced, I don't know what cylinder that is. Okay? So you can use your scope to do it. You won't get a fancy-ass box, but you'll get a reading, and we'll tell you how to do that near the end of the class. We'll show you how to do it. Okay? You could also do running compression on a vehicle. And running compression, I used to sell a lot of fuel injection cleaner. And use something like Run Right. You clean out all that carbon. You take a vacuum reading prior, vacuum reading after. You take gas analysis before and after. And you do running compression before and after. And I used to print this stuff out for them. Man, you have that customer on your side. I used to get $300 a pop. I told them if they didn't like the way their car ran, if they weren't convinced, I give them their $300 back. I didn't give anyone $300 back because they felt the difference in their car. Okay? And this is one way to see how the engine is breathing. So for you guys that don't do that, you really need to check it. And can be done again on every scope. And you can see what we're doing. As I'm going through each scope, I'm giving you little tidbits of information. Buttonology, I'm not going to kind of go through this because there's not many people out there. I put it in there when I developed the training program for them. We had to kind of tell you what all these keys did. If you own this unit, and I think I've seen a couple of guys come in with the box with them, you want this page because it's going to tell you what to do. Okay? The master reset. This is real important. First of all, I want to say, before you do a master reset, never ever leave this thing in the charger. Like a lot of people would buy these. They think 24 hours or 2 days is even better. You pass 16 hours on this NiCad battery, it's gone. You're going to lose its brains. One way to try to save it, is hold the F5 and the power button down. That's F5 and the power button at the same time. This does a master reset. It loses everything that's in the scope, kind of refreshes it, sees what's what. So here's the power button. Information button gives you a lot of information on setups, what to do, yada, yada, yada. You can change a lot of different functions. Instrument setup, pretty nice. You can set this up for different printers. Pretty much all of that neat stuff that you can do with a lot of the other ones. Smooth, if you got signals that are very hashy, you may want to smooth it out. A lot of guys, again, when they use this type of scope, they use the blue filter. I never use the blue filter for an oxygen sensor. And here's where my oxygen sensor reading would look different. The only reason why you're going to use the blue filter, if you went into air fuel, it would tell you oxygen sensor test. It'd tell you to use it. When I go into scope, I never used it. And the reason being, I didn't want to take more stuff out than I need to take out. The more stuff you got to take out, you're going to lose it, break it, leave it under the car, or whatever. That's how I operate. Okay.
What is the blue filter? Is that an attenuator or something?
It's a 10-to-1, yeah. It's a 10-to-1 filter. Okay. And here's just a lead setup. You could print out to just about any printer. You don't need to use their current probes. You can use any probe on that as well. And we're going to stop at this slide so you can take a break. Here's what we talk about, the common port. If you're ever doing ignition, and in my personal opinion, no lab scope is real good on secondary ignition. That's why I don't even bother with it. Secondary ignition could burn your scope up. You've all seen, you got that metal clamp on most of them? You got arcing wires. If your ground comes loose, it's going to arc through there. That's going to go right up into the scope, and it's going to wreak havoc. I know a couple of my students, one guy that I just thought of recently who passed away, Ruben Santiago, nice guy, he burnt his unit right up, okay, because his ground wire fell off. An ignition scope is an ignition scope. This is not. Use your lab scopes on primary ignition. Does that make sense? So as we were talking about the isolated grounds, you know, when you look at it, and how come we don't put the ground to a battery? Remember, we could have AC voltage. Remember we went over earlier. You don't want to go to the battery. Try to go to a good ground. Make sure that ground is clean and good. That way you could separate these different channels on all the different scopes that are out there, with the exception, again, a lot of the newer ones tell you it's an isolated ground, okay? Because the wires are misleading. One of the nice things they did here as well, they showed you on their information what to use. We were talking about like 1,000 to 1 if you were doing something on ignition. They kind of told you where to hook it up, what to do with it, okay? Here's some nice stuff here. The plot reading, the min-max. If you were looking for a problem on a scope, here's where guys don't go. Remember I told you about tightening the time up, slows the unit up? You got so many samples per second. A lot of guys went to flight record, and flight record, you have an endless loop of 40 consecutive screens. When it loops from one to the other, if you had a problem, you would never see it. And here it looks like the signature. Here's where people always screwed up and they couldn't find the problem. The next one here is the intermittent record, but it only does 128 consecutive screen or 64 for 2 channels. Now this brings up all of the scopes we just went over, Modus, Genesis, and this Fluke unit. When you put the second channel on or you put glitch detection on, you're dropping sampling rate. So if there's a problem, you may not see it. When we talk about the next scope we're going on, that does not drop any sampling rate, okay? So you got to know what your scope can do. How many guys knew that your scope dropped out? You didn't get the highest sampling rate. Some people don't know that. You think it has the best sampling rate. It doesn't. It drops off. So please be aware of that. Just some information, scope information there that you could use pretty much on any type of scope. And here we're on, since it's only a 2-channel, just a little movie, you're going to see the oxygen sensor and the fuel injector, just to show you fuel control real quick. So if you're looking at the line going up and down, you'll notice that injector is moving in and out a little bit. This is what you'd like to see at idle. And again, why isn't the fuel injector going like this, up and down, up and down? I'm at 2 milliseconds so I can see the fuel injector. If I wanted to see that go up and down like this, I would have to be at 200 milliseconds per division. Does that make sense? So that's why when you have one time base, which every scope we're talking about, except when we get to the very last scope, it's the only one with 2 time bases. Years back working with Fluke, I had a 28-channel lab scope that they were testing out, and I was doing that testing for them to see if it'd be good in the automotive market. This thing was so complicated, and never forget I had Pierre and a couple of my other students come over that were good with scopes, and you couldn't see anything. It was like a data logger box. The only time you seen it is when you put it down to your laptop. So you were recording all this or setting it up, going out, 28 channels, good if you had a dropout. The amount of brain power you needed to use this thing, it really never made it in the automotive field. They were looking at it. They used that, again, very expensive piece. They use it in the electrical divisions. Now this scope here, the 192, this is a 60 megahertz scope. I have the 196 that I like. It's a 100 megahertz scope. The state of Alaska, I did a 40-hour class where the guys up there got to get this scope. It's about a $2,800 scope. It is all CAT certified. Yes, you can use it on hybrid, just like the Fluke 98, but this is isolated grounds. This is faster. One of the things about the state of Alaska when they gave this away with the AES lead kit, the guys had to sign a disclaimer. Any of the leads they used were not to be used on high voltage because they were not certified. They were to be used on low voltage vehicles and not to be used in industrial or household voltage or current, okay? They were able to buy the leads if they liked, if they chose to do so. And the leads come with it if you just bought the kit direct from Fluke. They don't give you automotive leads. They got an amp clamp. They got an ignition setup, and they got a temperature probe. So they got a whole package. They had to pass 100 test questions, get an 80 or above. Anything under an 80, they didn't get to keep it. They had to do hands-on in the shop. If I told the guy, give me cam and crank sync on that car. You give me fuel injector and O2 sensor. You give me map and TPS, and mix them around. The guy would have 20 different problems to do. If he missed 3 or 4 of them, he'd fail that part and couldn't get to keep the scope. So we only had a few people fail, and I say a few, probably about a half a dozen or so. Most of them did get it because they realized, number one, they'd look silly, they'd be out of the emission program, and they wouldn't get to keep about $3,000+ worth of equipment. Okay, so that was pretty nice. And one of the things Fluke did is they took suggestions on all scopes out there. We told them about the Snap-on, the OTC, Tektronix, Pico at the time, Fluke, obviously, and OTC Perception, maybe 1 or 2 scopes, most common scopes in the market. One of the things they look for, number one, the scope had to be made in the United States. You probably all heard of Senator Stevenson up in Alaska. He's pretty big on keeping things in America, and something that they had to look for it. They also have to look that the unit would last for 15 years. The only one that came up, or the only 2 that came up, everyone else was thrown out at that point, the Tektronix and the Fluke are able to last out for 15 years of life, of when they did this about a couple of years ago. This unit is so fast as we're going through it, I got to use the slowest speed on this scope, and even that is sometimes too fast for the automotive industry. So this ain't going anywhere because in electronic industry, IBM, Xerox, and so on, they use this scope. This is what a technician comes out to diagnose something with. Here, as you can see, I'm on an ignition signal. And I just told you, I don't do secondary. This is primary. And what do you notice right away? And all I have here, for you guys that maybe don't understand this, all I have is 1 lead on here. 1 lead's going to ground, the black part of the lead that separates, the red lead is going to the negative side of the coil. What do you notice here?
Primary, secondary rates.
I got a problem right here. See the little fuzzy wuzzies? This is what we would call on an ignition scope superimposed. Means if this was a 4-cylinder, 6-cylinder, 8-cylinder, they're all overlaid on each other. If I had no misfire, I wouldn't be getting all of these little lines breaking up in the background. They'd be pretty close to this right here. This is the coil oscillations. This is the time that the coil is saturating, called dwell, and that's the firing line. You've all, over the years, seen raster. What's raster? Stacking of the pattern. Or display. What's the other way? Display. There's another word for display. Parade. So it depends on the unit using. Parade or display is all basically tightening this up. If I take the time, rather than 1 millisecond, I make it 20 milliseconds, all of a sudden I see a lot of peaks going up and down. That's all that is. So again, I look at primary. If I see everything is hunky-dory here, what am I going to bother going further for? Pulling out secondary stuff, I don't know about you, but it's a lot of aggravation. I get paid by time, and time is important to me. So they have a pretty nice setup. The buttons intimidate the hell out of people. These are some of the slides that I gave a guy when I do a book. We're doing that hands-on class, like I said, starts Friday. And a guy that's going to come through with any scope, I'm going to give him a pictorial of his scope or her scope. Because the simple reason, you know what? You forget all this stuff. And I don't mind when people call me up. I got the unit next to me. I could say, hey, hit this button, hit that button. Okay? It's pretty neat when you have it. So you got on, off, all of these things, up, down. At any point on this scope, what I like, I can move the signal up or down, right or left, or do anything I want with it, including play blow up. Blow up, I can blow it up to 16 times the actual size. So I could pick out what's breaking up in there rather than viewing it. When you get old like me, you need the blow up, okay? And I'm not talking about the blow up doll, guys. Nasty thinkers that you are. Okay, Labscope meter recorder. It records stuff, which is neat. By the way, you see this thing called replay on this side? You never even have to hit the record button. One thing I like about this, if I have to go get a cup of coffee or tea or whatever, or a bottle of water, I could have this on the car. If it had a problem, I come back, I hit replay. It's like looking at my scan tool. It recorded everything. And I could play it back frame by frame. I could blow it up, do whatever I want. I could use those cursors on it to measure not only voltage, or time. I can go up and down with the cursors, or I can measure it this way as well. Put all 4 of them on there.
How long does that record?
Has a pretty big buffer. I forgot how long, but it's more than minutes. Yeah. Oh, yeah. It does a real nice job. And again, this is for glitches in the electronic industry. And I forget the exact time, but put it this way. What I like is any time I've ever hit it, I've seen the problem. Unless if you go there and you exit it, and then it says, do you want to exit the playback mode, and you do that, you just lost it. You can save it. It saves 2 movies. It saves 15 screen setups. So even if you didn't have the brain power, I worked with George Menchu on the AES New Wave that he has. It's a different version. And the New Wave, what it does, it takes the 190 series stuff and puts it in there. You could take a setup, let's say you want MAP and TPS. You want fuel injector and evap solenoid. You hit the button, it throws it right into the scope. You go to preset, now you're all set up. The problem I have with that, that's good in the beginning, but you guys really need to know where to set your voltage, where to set your time. Okay? It's good for a starter. The AES Wave is good to save everything in because you could print everything out and give it to the customer. And that's where you make money, giving it to the customer. Okay, now, one of the nice things here, you see this thing glitch on or off? This thing is so fast, I never use glitch on, ever. Because it just catches everything. So I always tell guys, and this is one of the screens that they would get, to turn that off. Okay? You can go by and put averaging on and off. You can make a normal waveform, a persistent waveform. You can do a whole bunch of stuff. Half of the things you don't even need to use. When you get into it, you can see that you can do anything with trigger. You could do an external trigger like your timing light. That's what trigger is, right? If you were on a 6-cylinder motor, you could put it on number 1 and see 10 degrees on a Ford, or put it on number 6, they're 180 degrees apart, right? But that's if you want to do external trigger. We normally on scopes do internal trigger, meaning you're triggering off the oxygen sensor, TPS, mass air, whatever. That's what we use. And you could trigger only off one, A or B. So you can go up and down with it. You can do a whole bunch of stuff. Now, here's the neat thing. You see this here? The full bandwidth is 60 megahertz on a scope. 20 megahertz is even too fast for any signal on a car. Usually, I pick 10 kilohertz, and you grab everything. Now, the reason why I get the top speed, when these guys are using it in the electronic field, they got a lot of stuff on these mainframes and so on that's at fast speed. This is why this unit won't be dead, or the Tektronix units won't be dead in 15 years. They even have kits to do fiber optics and stuff that are add-ons on these. Okay? So this is a very, very fast scope with a lot of capabilities that's not as hard to use. I'll be honest with you, you'll see at the end of the scope section here, the first scope I pull out for a problem, if it's only a couple of channels, is my 196 scope. It could take a 6-foot shot to the floor. It gives me good amp readings, good voltage readings. It's durable as hell. You could save it. The battery lasts 4 hours, which is another plus for me.
Jerry?
Yes?
How do you stack that next to the Pico?
It's a totally different animal. If I had my choice, I'd rather go with this than that. Not that Pico's a bad scope, but
Well, it's a big difference. One's PC-based, one's
right.
handheld.
If I got to turn my laptop on, that's time. And Murphy's Law, a bottle of water may spill in my laptop. Grease may go in there. Something could happen to it. Okay? That's as if I have like a Bernie Tower, I always have it on, or a Nello with his truck, it's on all the time. I kind of like something like this that I could pull out. It's hybrid ready. It's the first thing I pull out. Chris will tell you when we did the hybrid class, you saw, in fact, the trailer. If you guys were in here earlier, you see some of the pictures. What did I have in there? It was that scope. It works real, real well. Okay. And again, I don't sell them. It's not a commercial for them. One of the things I like here, you can do voltage. Remember, we want to set our amp clamps on voltage 100 millivolts for the best resolution. So whatever your amp clamp says, go to the 100 millivolts, and that means every box on the scope, every little line So if I select 100 millivolts equals 1 amp, if I start here, that's 1 amp, 2 amp, 3 amp, so on. Okay? That gives you the best resolution. Now, I could change this, because I'm blind, to 20 millivolts. 20, 40, 60, 80, another line would be 100. That way it's bigger. When I lower my voltage or lower my time, I make it bigger. Good for us old blind people, okay? You want it smaller, you just go the opposite way. It's not rocket science. And that way you can get in there and really see if you got a problem, blowing it up. Okay. So here you also have the leads that come with the scope are 10 to 1 if you buy it off Fluke. If you buy the automotive package, you got to switch it over to 1 to 1. You could go up to 1,000 to 1. This thing you can read, it has 10 lines going up. It's certified for 1,000 volts. So you can read anything out there safely without getting hurt. You could zoom up or down. This is a zoom function. 16 times. Now, it's not going to be like I'm going to show you on Pico or on the EScope. Bernie's is indefinite. I mean, you can just keep going with Bernie's and blow it up, and you'll see that. I will do that in a little while for you. You can just go anywhere with that thing. Maybe you don't need to do it, but this has some function of going up or down. And when it's zoomed, I like that you could go up and down, right or left with the zoom. So you don't lose anything. Let's say I blow it up and go, it's off the screen. Move it down by your soft keys here. Move it right or left by the soft keys as well. Nice setup. Here's a little video. Watch this. This is my 196. Notice that this scope, 100 megahertz. They have the 199, 200 megahertz. Overkill. Nothing you're ever going to work on a car is going to be that fast. Not for now. Not for quite some time. So I'm hooking up to an AC signal. There's a whole bunch of static going across. I just put the scope on. You're going to see the blue comes in as an AC sine wave. The red, of course, you're dizzy now. I'm trying to set the scope and do this real quick because I'm too lazy to get the tripod, by the way. Got to be honest with you. But watch this thing starting to come in. And I slowed it up. That's the only thing I did for you. I slowed it up because I'm not that slow in the head. Okay, you can see I'm starting to bring it in. There's the square wave in the background. Okay, and here's the AC voltage going in, and it should come down any second now. If I made it run at the normal speed, it would have been done real quick, but I wanted you to kind of see, there's our square wave, there's our AC, and you could do anything at this point, freezing it, expanding it, play it back. Let's say you had a dropout. You guys all heard of Orange County choppers, right? Well, one of the things that's even in my Labscope book that Ralph and I did is we took one that I did in a class years back. A guy brought a car in that used to work for Orange County choppers, and he brought this Camaro in that had the 8-cylinder motor, and we all know what the 8-cylinder motor has, right? Has a distributor behind the water pump. And that distributor is the cam and crank signal, has the blade. Well, we hooked it up because he had a code, he had a diagnostic trouble code. Wasn't a scope class, but we said, hey, we might as well go into the 4-wire plug. The 4-wire plug has ground. Remember I said never be afraid of it? 12 volts. High data, what's high data? Has 360 holes in there. So that means 720 transitions, high, low, high, low. That's a transition from high to low. And then it had 8 little ones for 8 cylinders. Well, we seen the thing dropping out. I said, dude, you need a new one. And he was in a couple of classes during the week. Comes back the next week, he goes, it's running better, but I still got a problem. Can you take a look at it? He put a brand new one in from the dealer, and this is why you got to scope stuff out. Just because it's new doesn't mean it's good. And this wasn't rebuilt. This was brand new. Put it in, sure as hell, when we did something just like that, where you look at the signature, remember signature, is just to see how it looks. Couldn't find the problem. Stare at the screen. You could even hear it hiccup. Stare and stare and stare until I took it and tightened it up where you got it real tight like this, and then all of a sudden there was your dropout. So if you look in my, I forgot to put that slide in here, but if you look in my Labscope book, that's right in there. Tells you just what I've been telling you the whole night. Tighten the time up, you'll find the problems a lot easier. That's what that guy Pat Adamowski did, who made the perception. Okay, he was with UEI. He had that glitch idea because he understood how a scope worked. And now I'm telling you how it works because I've been doing that same thing for years. Contrary to what most scope books tell you out there. When I learned scope, they never told you to do that. They said, nope, 1 to 2 complete cycles, everything's hunky-dory. That's a bunch of bull. Okay? You want to find the problem, you need to do that. Any questions? You guys are way too easy. Now what we're going to need to do is steal this chair from Mr. Norman. Thank you. ES or Pico are basically the same thing. The 2-channel ES is a nice scope. The software is a little bit different than the Pico, but it's only 2-channel. The Pico is a 4-channel scope. The 4-channel scope is pretty nice. You can do a lot. You can play blow up with it. Pretty simple. They have some preset settings in it, which is nice. Okay? Of course, you could print. You can do a whole bunch of stuff with it. It's a nice unit. Approximate list price, I believe, about $2,200. That's the Pico 4-channel. The other ones are about 1,000 or 1,100 ES or the Pico setup. Same box they use. ES software in certain aspects a little nicer. And again, you know, since I have them, I play with both of them. But I'm going to concentrate more on the Pico. You got 4 colors, as you could see. All your voltage and your times are up there, which A is blue, B is the 2nd channel, and so on and so forth. The nice thing is, when you get into it, you could make it DC or AC. You can go down to the bottom, and you could trigger off any of the channels, only 1 channel. You got 1 time on this, but they got some nice presets. It has some nice stuff. You can move, you see the little bar here? You take your cursor, and you can move that up and down. Take your little pointer up and down, and you can make the green go to the top, the bottom. Pretty nice. Anything in green, you know, when you look here on my green scale, it tells you how much my voltage is from top to bottom. My blue scale, my red scale, my yellow scale. That's pretty nice. Pretty neat setup. Okay. You can see I got an injector here. I start putting cursors on it. I can measure with the cursors what the voltage is up top. Okay. So I could see what pulse width is, whatever I want. You can put them on, you can put them off. Pretty nice, pretty easy. Okay. In fact, the last hybrid class we had, she couldn't use it. It was a girl from California, I forgot her name, but she had a Pico scope that she wanted to use, and on non-hybrid stuff, she was able to use it and capture certain things. Fuel pump, current ramping, and waveform. She had just bought it, just got into scopes. Pretty nice scope if you just got into a PC-based scope. Very user-friendly, I must say. So here you can see I'm starting to set up ignition. You can see some of the noise here on the yellow channel, and I got to go over here and see. Yellow was my oxygen sensor. Green is my TPS sensor. So same thing I did with Modus and Genesis, pretty much same setup. I raced it up. Idle, race up. You kind of see the same thing you've seen before. What happened to the green line that was down? It went up. My injector went wider. If I wanted to measure pulse width, I'd take 1 cursor here, 1 there, look at my reading. I want to measure peak voltage. I put a cursor across the top, cursor across the bottom, and I'll see what my peak voltage is. Personally, I don't use the cursors. We're not picking the pepper out of the fly shit, right? When I got to look at something, I just hit hold on the screen, I freeze it. I can count up very easy rather than playing with a whole bunch of buttons. And there's usually nothing, in my personal opinion, that's that critical where I got to start using the cursors. Some people want to use them. That's okay. I don't have anything against that. But again, time is money. There's some things that are nice to do, some things that you have to do. I can count. It's pretty easy. We got some presets. You can see the pull-down menus. You can do a lot of different things on the channels. You got a sensor setup. Your handout, I believe, came out pretty good where you can kind of read that pretty good. They got not a lot of setups, but you got a few. You know, what do you got there? Maybe a dozen? But you know what? It'll get you in the right ball game. But here's the thing, gentlemen. Presets get you on one channel. When you got a problem car, you want way more than one channel. You want to see what's going on multiple channels. Does that make sense? Okay. So here, just the blow up, you can see the time up there. The other thing is, you notice how the injector got bigger? Let's just pop back so you see the injector. You know, it's not as big. We blow it up. You see what I did here? Everything is 1x except I put 2x. You could keep zooming this up. If you notice, if I keep zooming it, you know how Bernie on his scope always makes the bottom of a fuel injector look big? You could do that here too, which is kind of nice. They do have a decent type of scope. Now, this scope is totally different. It is, and by the way, Pico, not hybrid, cannot be used on hybrids. It's not certified. Bernie's scope can be with special leads. You need to buy, right now he doesn't have them available yet, but if you had a set of Fluke leads that are certified or Tektronix, you can use the scope on that. The thing that I made him do was put this yellow button in. Now last month, I know he was our guest speaker, some people get a little confused, to say the least. Bernie is way up there. Okay, he's one sharp dude. Either one. He's Von Braun, I'm the dirt on the ground, is what I have to say. He's one sharp dude, and he thinks out of the box. He does different things. And I got to tell you, the guy fixes cars. Haven't been to a shop in Albuquerque, New Mexico. This dude can diagnose and fix stuff. He just gets so excited about his product that for him to tell you something simple, that lasts for about a half a minute. Then he's into some molecular structure and, you know, taking over the world or something. I don't know. Whatever he's doing. But he is a great guy, makes a good product, and he listens. Because I said, look, you are never going to sell any of these things because guys don't understand scopes. So you need a button. And since he likes yellow, he did the yellow button setup. With the yellow button setup, this is new. None of you guys have it who own this scope right now. He has put presets in there. Air condition, anti-lock brakes, body control computers, engine performance, light circuits, starting, supplement, restraints, and transmission control. You click on it, look at all the stuff in engine, and it keeps going. All of these are just like any other thing on, you click injectors, goes to another menu. And I'm going to show you a little bit of a live stuff from it. Now he shows you where to put it. Because you know what I found? I've been teaching since 1979. You guys need guidance on where to put it. Now, not at night, Nick. That's a whole other ball game. If you put in the wrong hole, that's your responsibility. Okay? But yes, you do need to know, and now it's all drawn out for you. The next step, what he did, is you could apply the setup. So let's say you pick something, cam and crank. You hit the button, apply the setup, the scope is set. All you had to do is mimic this picture and put where you want it. The other thing is, this is why I need the chair. Watch this, gentlemen. The nice thing that he does, so this is the real scope. I'm just not hooked to anything. I got it in demo mode. I hit this setup. I go into engine. I'm going to go down to injectors. I'm going to take a saturated drive injector that we just talked about. I could apply this setup, or I can do this, and this is going to take a second to load. It takes a second because it's a flash file. If you had a brain fart when you're doing this thing, not only can you review it at home, but you can review it right on your tool. He talks over this. I have the sound off, basically showing you where to hook up your amp clamp, where to hook up. And the amp clamp, by the way, could be on either side of there. Doesn't matter. But the voltage has to be on the side that's being controlled by the PCM. He has this, and anyone that owns a scope will have every single thing that's in there, cam and crank, whatever. This is just-in-time training. He went the next step. So not only now he's telling you where to put it, but if you don't know what the hell you're looking at, I know where to put it, but how do I know it's good or bad? He'll explain it to you. Now, are you going to need to look at every video? No. But sometimes you'll go, I really don't know how that evap solenoid works. I need to review that. He has it in there.
Can you buy just the video? Just the software?
I've been asking him to do that. Because, see, I knew someone would say that. Because that's how I think. I said, hey, you're spending a lot of money putting this in your scope. Why don't you sell this as a separate thing? You know, it was like years back, the Bear division had something called flow charts. Flow charts, of anyone who worked on a Bear machine, was some ass-kicking information. They had color wiring diagrams. They gave you just-in-time training. Here's how the TPS sensor works. Here's where your wires should go. Sometimes we all need that, don't we? Okay? I mean, you know, for me, again, it's easy when you do it every day. Now, here's the other thing. You could load any setup you want. Oop. Yeah, let's cancel that. Come on. Oop. It helps when you click the right button. Kept hitting the wrong mouse pad. You can make any setup you want. Now, here's where you all get confused. Let's say I wanted to look at 8 injectors, 8 coils, 2 crank sensors on a beamer and a cam sensor, and the TPS and the O2, whatever. I can make any setup I want. I could email you the file, and you could do it. Now, what you have up here, this looks like it's all Greek to you. Number 1, the yellow is going to be a fuel injector. Now you all see it's a fuel injector. I could take off all these other channels. These are 8 channels. Up top, this is where I'm triggered on this. I'm triggered, as you see, triggered scope. I also am graphing if there's ever a dropout, I could see if anything ever dropped out. If I forgot and didn't look at it, you see this? You see everything moving back and forth, gentlemen? You see the green drop out? You see the green drop out to my, oh, no, you can't see that. Why is that? Oh, I know, I blew his scope up, hang on. No, for some reason. Yeah, I don't know, I guess when I blow it up you can't see it. But watch the green. See this green going up and down? Everyone see where my cursor is? Watch this. You guys see the dropout in there? There you go, look at it. So whether I'm looking for it or not, I could find it. Not only that, watch this. I can do the same thing here on the injector. You see the bottom? This is all different stuff going on. I could take it on or off. This is called his strip chart, or strip roll chart, I think he calls it. Strip chart. This means just like your free run, or like Modus had to pick anything up, picks anything up. So whether you had a signal or not, it'll give you something. Notice the top one, I'm at 80 milliseconds for the whole screen in time. Look at the bottom. I'm at 10.2 seconds, gentlemen. 2 time bases. So if I wanted to see the oxygen sensor go up and down, I can do it. If I want to see something at a different time, I can do it. If I go over to the 8-channel scope, and if I already preset this and save this with the injector up there, all I need to do is do this. Save custom setup. Save custom setup, I'm going to make this G. You see how that injector looks, right? Now I'm going to screw this all up. It's all gone, right? Just look at that one, never mind everything else, right? I'm going to do load setup. I'm going to go to G. Did it just come back? That's how easy it is. It's not hard to operate. So you can do anything you want. And again, Bernie showed you some of this. Now, you're like, I can't operate that thing. Let me show you some other neat stuff that no other scope has. First of all, this deep record thing, this is nice if you got a problem. I really don't have to use it much, but I'm going to show you something. When you stop the deep record, I can do a couple of things. Let's say I want to move this up. I can move it any way I want. Similar to the Fluke zoom. I could zoom in on something with zoom window. And this is what Bernie always does to you. Right? And you're going, you can see the yellow, right? You can see the yellow. And of course he's not hooked anything, there's interference, just a play file. I could take everything else off the screen. So watch the orange go bye-bye. I could put everything back on the screen. Never lost a beat. I could move everything. I could reset everything. It's all there. Now, how many times do I have to use that? Not many. Like I told you, this is a good scope. What I personally use, I pull out, you need at least 2 channels to see what's going on. When there's a nightmare, I'm going to pull this out because I got 8 channels and 2 time bases. The other thing that you probably don't know that he does, first he has meters. So for guys that like looking at meters, you still have that. And by the way, all this time you were still graphing. So, ooh, I must have missed something. Up, look at the brown. You see the brown on the bottom? Look at the difference on the brown, very bottom. You saw the flat spot, right? It's all there. Here's the other nice thing. How many of you guys want to put a solenoid on a vehicle? You want to make that EGR open up. Your scan tool don't have bidirectional control. Or the evap solenoid or anything else. Anything that is powered, if you use ground, you go like this and it's going to warn you that you know what you're doing. Of course, if you have it in the wrong hole, if it didn't need a computer, gentlemen, it now does. Okay? So you got to be careful. You do this, and what it's doing, it is controlling that solenoid. You could change the frequency, the amount of time something happens in a second. So let's say you want something to duty cycle at 50%. Let it do it. How many seconds it stays open? You could see if something's working on that tranny solenoid, that evap solenoid, that fuel injector. And if you're going to do fuel, you better be careful. You could hydrostatically lock a motor if you don't know what you're doing. That's why it says, I know what I'm doing. But I've seen a lot of people check they know what they're doing. Okay, your laughter tells me. Now, here's another nice one. How many of you guys have come across a no start? And this is all built into the tool. You've all purchased sometimes signal generators, although you can make one from Radio Shack pretty cheap. But here's a nice thing. I can make, if I have a bad crank sensor, I'm going to make an AC generator crank sensor over here. Oh, the voltage is not high enough? Not a problem. I'm going to change that right now. See the yellow line get bigger? So now, and it can change your frequency. If I got a no start, I go right down to the sensor, send this puppy to the computer. If it wants a kick and it's just not right, I just change the frequency. I'll start the car up, gentlemen. If I need a cam sensor or any other type of square wave, I'll go like this. I'll make a square wave. If I need bigger voltage, not a problem. I got big square waves. I need to change the frequency. Pretty neat.
It's a $1,000 diagnosis.
You know what? Once you use it, and you know, some of my students that do have this, if you know what you're doing, are you going to need to use this every day? No. But you know what? You got a mass air that you just heard back there. You got an ABS wheel speed sensor. You got something that's not right. Not only could you put this on the scope and monitor it, but you could put the signal out, you could activate stuff, and you could record the whole thing and print it out. And if you don't know what you're doing, it plays a damn video for you. Pretty neat stuff.
How much was the scope again?
Got to ask Bernie, but for a TST member, you call them up and you tell them you're a TST member. You're seeing it in here. I think it's like $4,500+ with your own laptop. If you buy the laptop off him, it's about $900 to $1,000 with a Dell computer, depending on the price of computers that day. Okay? So it's a pretty easy scope once you understand what you can do with it. It's hard if you don't know what you're doing with it. So let's move on to other stuff so we can kind of get you out here on time. Any questions on that? Pretty simple. And again, you know, he didn't have this in there. I just look from your standpoint. Having taught a lot of you, some of you guys have been in my classes, I just got to look at, hey, guys don't have the time to go jerking around remembering how to use something. That's one good thing that Snap-on has done for years, and one good thing that OTC does. They give you a lot of that information. The information is valuable, but now you need the tool that can do even a lot more. I'm not here to sell you any equipment like I opened up with. I'm just here to show you the facts. If someone else built this, I'd put it there, okay? Pico sells my Labscope books. Bernie doesn't sell my Labscope books. Okay? I'm just showing you the true fact of what's in there, what's not in there. You make your own decision on what you need. Okay? Because I know I'm going to get some hate mail. Obviously, someone's not going to like what I said or didn't, and that's just the way it is. I tell the truth. If they can show me something different, if I omitted something, I'll be more than glad to put it in. But this is on my own findings with help from different companies. Let's talk about MAP and TPS, mass error TPS, excuse me. Or it could be MAP. Notice what I did here. I slowed it up. If I didn't slow this up, when I raced it up, what would happen to this line? It'd be a straight line. Would I ever see if I had a breakup? No. When we're on a MAP sensor, what's a good voltage at idle? With good vacuum in the motor, 18 inches of vacuum roughly. Somewhere about 1. When you race it up, if the line only went up and down, you wouldn't see if this thing is breaking up. What happens sometimes to these MAP sensors? Inside of them, they start breaking apart. Maybe gas vapor has gotten in there over time. You've all seen hoses collapse, right? So when you race it up, you'd want to see, are we getting any breakup? TPSs nowadays are a lot better than they used to be. You don't see them failing going up as much, do you? Mass airflow sensors, you do see starting to break up, right? And a lot of times the mass airflow sensor, first thing to do is look to see if it's dirty. Is there a leaf on it this time of year? I remember one of the things I put on one of my classes, there was actually a leaf we had on a car. It was running real bad. It was right on the mass airflow sensor. It was stuck right on the wire. You know, put cheap filters in or don't run a filter, this is the problem you're going to have. Okay? AC voltage goes above and below the zero line. When you're doing an AC wheel speed sensor, if you're doing ABS and you got a 4-channel scope, some of the ones we mentioned tonight, you can go right to the ABS computer and go on there, and that way when you're driving on a straight road, you want to see the amplitude. Amplitude, gentlemen, is the voltage height. You want to see the frequency, the amount of time something happens in a second. If you see that 3 of the wheels have the same amplitude, one has the same amplitude but it has a different frequency, we may have a problem with the wrong tooth being in there. You remember some of the articles that we've had over the years in the TST magazine, okay? Someone puts in a wrong flywheel, whatever, okay? One of the questions asked at break time, where do I get a good load of waveforms that I can compare to? Remember what I said before, and a good car is the right answer for your scope. When you start changing scopes from one scope to the next scope, you're going to run into problems. Why? Every scope, what I told you in the beginning, draws a little differently. When you go on, and IATN's a great resource, Identifix, phenomenal, okay? The problem is, how do you know if that guy has a new battery in his amp clamp? How do you know he's not next to some alternator or a drop light? How do you know his scope, you know, is really zeroed? How do you know his leads are good or where he's really connected? You don't. And when you try to compare, even in my Labscope book, we give you some pictures, but this is generically what it's going to look like. You start measuring stuff up like a lot of guys do, you better save it on your own scope. Again, the AES Wave, phenomenal to save it on, because you can compare. The Modus, you have your own thing, make the bitmap. The Genesis, you can do a similar setup. Save your own information, makes a big difference.
Gary?
Yes?
AES Wave is sort of like the universal program to save all from different...
Yes. George Menchu has a lot. You'll probably speak to Carlos or Mario. Carlos is his brother. He has 2 different versions of the Wave. There's the new one that does that 190 series and a lot of oddball scopes. You could put just about any scope, like the LS2000, like the old Intero units, like the old Perception. The Vantage you could even put in there, even though Vantage makes its own software. Same with Fluke, made their own software. You can put it in there. I use it because a lot of different scopes that we have, I could save the pattern from it. Now, granted, if you look at my Labscope book, I do get lazy once in a while. And if I pick up a scope that's easier to do, to download it, I'm going to use the one that's easier to download rather than going through 9 million bells and whistles. And what I mean by that, not that the software program is hard, it may be what cable or what connection you need for that particular scope. So that's how I determine what I'm going to save. Let's face it, if something's on the Pico, it's real easy. When I did some stuff for them, I took screenshots, piece of cake. Bernie scope, piece of cake. You know why? Print screen, I'm done. Even if I didn't save it. Or I could save it as a JPEG. Pretty easy to do. You've seen some of Bernie's stuff prior. Here we talked about when we went to that battery. When we went to the battery, you wanted to check the DC volts, correct? Very easy to go there. This is just like a meter, like we said before, nothing to be afraid of. Red lead, black lead. When you're in there, check the AC voltage ripple. If that voltage ripple is bad, you're going to run into a problem. Let's show you a problem from the MT5200. Let me see where I put it. Here's a problem, one of my students who sells Tektronix stuff. So this is the MT5200. Nice scope up there, probably 6,000-ish or so or more dollars. By the way, not hybrid safe either. Not hybrid certified, not high voltage CAT certified. Here's a vehicle that he's looking at AC voltage when a guy is trying to reprogram a Nissan, I think it's a Sentra or some Nissan. I forgot what it said. Well, some sort of Nissan. And you can see the AC voltage going across. Bad, good. Just different stuff, how he's measuring DC volts and how he measures stuff there. If you get into reprogramming, they want a steady voltage. They don't want interrupted voltage, okay? They even sell special battery chargers to keep the voltage at a certain level so you don't ruin anything. Your lab scope could be real helpful to see prior to you going to do that, do I have any AC voltage? And again, there's always some AC voltage because the diodes can't eat everything up. Does that make sense? So make sure you take a peek at that before you do anything. Any questions on that, gentlemen? Here's cam and crank, and on this particular scope when I took it, it's just the background is taken out. A lot of scopes, I can't move this from side to side. And do you know what I mean by that? Maybe you want the cam sensor right in the middle. And in the middle, I should have so many square waves. Because the reason being, when we get on a cam and crank and we want to know where sync is, if this is my cam sensor, okay, and I have something like that Jeep we wrote the article about a long time ago, and the Jeep had 1, 2, 3, 4, but it had 1, 2, 3, 4 again, and another group of 4. If it doesn't come in under here or under the low part, okay, then you know you're off. Your timing is off. Does that make sense? So a lot of times you may need to move the whole picture one way or another. Go back and practice on your scope. If you can't move it back and forth, sometimes you get pictures like that and you can't get it where you want. Same on ignition. Remember some of the old ignition scopes? I'm talking the old ignition scope. The old ignition scope, you used to see this. This was your spark line, your coil oscillations, your dwell time started here to there, and that was your firing line, right? But how come on a lot of the new ones, what you see is like this, the lines here, you got the oscillations here, and you may see, it's all because the way you shift it. If you have the ability on your scope, all I need to do is put move, and I can make it look the same way as the top one. So some scopes don't do that, and if you recall that article on the Jeep, the guy who brought that into the training center, his scope didn't do that, and he wasn't too happy. And again, he should have looked at the scope in the first place and understand what you could see on cars nowadays that you can't adjust the distributor on. Is that timing chain or timing gear off? If you're supposed to have 1, 2, let's say 3 of these under there and you don't, and it's shifted more over, is the timing advanced or is it retarded, depending which way it is? So you need to look at. And how do you get good at this? Practicing on a good vehicle, okay? You know, in teaching those guys down in New York City, not only do I do scan data, key on, engine off, engine running and hot, 2,500 RPMs, 30 miles an hour, and 55 miles an hour. Do the same thing with Labscope readings. In fact, they're buying the Fluke Labscopes for the hybrids with the amp clamps and all that. I made them a whole book of just good known readings, and then we made some problems, and I said, here's what it looks like on this. Here's your good and bad comparison. That way, when they get a fart in their head and go, I can't remember what that guy said, all they need to do is hit the book. Hit the book, go, okay, here's what I got. Doesn't look like that. Here's my problem. Very easy when you work on fleet vehicles. Very easy if you specialize in Mercedes-Benz only, okay? Or BMW like Pierre. He knows those things like the back of his hand. No one's going to know it better than him. Why? It's all he does. So if you guys start building a database, and if you have, some of you guys have the Modus, some have the Genesis, whatever, and you share it among each other, at least you know, hey, that's a fellow TST member. I know I could ask him a question. Where did you hook that scope up to? You know, what did you do? I can't get that on mine. He may not even know he's doing something wrong. When you got someone that's thousands of miles away, you don't know what they're doing, okay? And it's not that I'm saying it's bad to look at that stuff, but you can't take everything you see as it's going to be the right information. You could sometimes mess yourself up, so be careful with that. Any questions so far? Okay. Now, here's something that, remember I told you if you can use a meter, you notice I have the Fluke meter here on the bottom? This is a Hitachi mass airflow sensor, okay? I cut out the scan tool part of it, but basically I also had the Tech 2 here, did this in New York City on a police car, and I'm showing them every 3800 motor runs at 2300 hertz, if there's no problem with the car. Remember I told you about baselining it? Prior to this screen I saved here, because they were using Fluke 98s for a while, prior to that screen, I did the signature. So it was only 1 to 2 nice square waveforms. Once I see 1 to 2 nice waveforms, I'm not going to stare at that anymore because I'm not going to see the problem. Okay, if you get nothing else out of this class, you're going to get, how do I find the problem? Do what? Tighten the time up. Okay? So here, you could see, if you could operate the meter, same pin, all I did was change from meter clamp to Labscope clamp. That's it. Simple. You could see if you got a problem. If you took regulated shop air and blew through the mass airflow sensor, I mean regulated, don't blow more than 7 pounds because you're going to blow that damn thing apart. Okay? Not 150, there's the disclaimer. Not 150. Ain't buying anyone no mass airflow sensor. We blow through there, you should see this change, shouldn't you? You should see the frequency go up. This thing goes to 10 to 20,000 hertz, okay? And if it doesn't do that, that's when you got a problem. If you took your other channel and went on the injector, what would you expect? The injector's going to move. Make sense? Okay. Now let's look at some of these things we have here. We're going to play blow up for a minute. We talked about injectors early on, but now I'm going to mess you up a little bit. Oop. Let's concentrate on this one right on the screen right now. Don't worry about the peak. It's probably going to be a little off. I can't get it there perfect. The peak's going to be off. What do you think about this injector? What type of an injector is it?
Saturated.
Good. It's a saturated drive injector. Any problem with this injector?
Why does it go down?
The bolt is going.
Why does it go down and up? Okay, now, there's nothing wrong with this injector. It is a saturated drive injector. It's from Toyota Motor Company. There's absolutely nothing wrong with it, but you are seeing this line is separated from that line. You don't normally see that, do you? You don't see this little hump here. By the way, you know what the Japanese do. They buy a license off Bosch, and they use Bosch injectors and circuits, don't they? Depending on how they use their driver, when this comes down, what's happening when you see that voltage spike? They're pulling away, aren't they? It rings out a little bit. This is absolutely normal. You'll find this on Toyotas and some Nissans and some on other Asian vehicles. There's nothing wrong with this injector. You see why matching up and understanding what you got? And all you did is go to a good known vehicle. Now some guy, when I first saw this, first thing popped in my head, I'll be honest with you. Whoa, problem. Not a problem. because the chances of all 4 of them being bad, and then another exact car with another 4 being, with no drivability issue, there's nothing wrong. It's just they do something with their driver. Does everyone understand that? Okay. Any questions on that? But that would fool a lot of people, wouldn't it? Right? You'd be fooled by that. Let's look at a peak and hold. Now, you're all familiar with peak and hold. What type of fuel system is peak and hold normally used on? Throttle bodies. It's always on throttle body. Most people think it is. It's not. Could be used on multi-port as well. Some of your 3-liter Chryslers, for argument's sake, and a couple of other vehicles out there will use it. There's 2 types of peak and hold. Bosch makes one of them with the drivers. The other one, obviously, is General Motors. If you looked at this, this is not a typical General Motors setup, because General Motors usually comes out, goes down, stays down the ground, goes up, and doesn't have as much as a little wave here if you were splitting hairs. You know what I'm saying? So this is a Bosch type setup. And when you're looking at, you notice when it gets pulled down, it really is on ground. What do you notice? Starts coming off ground. If we did current ramping on this, as voltage went down, what goes up, gentlemen? Amperage would go up. This would pull about 5 to 5.5 amps. It's a little bit more than the GM one. That's about 4.5 amps or so. When it goes up top, it comes down and it levels out here, and amperage would fall off there. This is called a peak and hold injector. The hold amperage would be about how much again? By about 900 milliamps to about 1.2 amps. Anything more than 1.2 amps does what? Burns the computer driver out. Good. Now, when you race the vehicle up, how do you measure pulse width on this? Do we measure from here to here, or do we measure from here to there? Which one? Here to there, or here to there? The first or the second, one or two, like a Chinese menu. A or B? You measure from here to the second one. When you race this car up like we were playing before, and I didn't have time to do that for you, if you raced it up, you would see this doesn't move, that does move. It's the second one. You'd have to look at that carefully so you know what goes on, because a lot of guys think they got a problem when this one doesn't move. What happens when you're racing something up and you shut it off? Most injectors shut off momentarily, don't they? This one comes in, that peak is still there, but it drops in. You don't see the second peak. That's its momentary shut off. Anyone ever look at a wiring diagram on this? How can they get 4 amps or 6 amps, depending on the manufacturer, how can they get it to pull that and then all of a sudden it goes down? The resistor, but it has 2 circuits on there, doesn't it? Okay, they switch it over in the computer. One has a good ground and one has a resisted ground, right? That way they don't pull all that amperage. Everyone okay with that? Okay. By the way, a lot of these are problem vehicles. What you're going to see is ringing here. Ringing means you're going to see a bunch of lines breaking up and down. When that happens, the injector is bad and your driver is probably about had it. Try a new injector first, but don't be surprised when the computer fails. That would be like constantly plugging your bad toaster oven in all the time, right? And the circuit breaker blows, you keep doing it, you buy a new toaster oven one day and the breaker still blows because it's weak. Same thing here. Any questions on that? Okay. Let's look at our last one, which is pretty expensive technology. Yep, I better do this. Easier to find if I do this. Now this one's a little different, isn't it? Anyone ever see this before? Sure you have. Where did you see it on? What type of vehicle?
A Ford torque converter modulating.
Okay, you're looking like an EPC type solenoid, torque converter solenoid.
The modulating.
But this is a fuel injector. You've seen this fuel injector. You guys work on Nissans? Sure we do. You just haven't looked hard enough. You work on BMWs, Mercedes-Benz, Porsches. This is what they use. This pulls like an EPC solenoid. Some of them will pull near 7 amps momentarily. This circuit, what it does is it goes down to ground. It does one of these and goes. When it hits ground first is where it pulls the amps. Remember, it's not going to do it more than 6 milliseconds, way less in fact. So amperage right here goes up, and then you know what these little humps are? Where do you think the amperage is with the little humps? That's the driver. They don't switch. They do it with the driver. It's doing this. It'd be like me doing this to a battery. Get it going. Once you get it going, just go. Because remember, it takes a lot of amperage to get something going, just like pushing a car. Once you give it the hard, right, everyone pushes, then it rolls, it's easy. Same thing here. So what do you think the amperage is there on this highfalutin injector over here? It's about 1 amp, about 900 milliamps. Same thing, different day. You put your amp clamp on it, guess what? You're going to see the little pulsing going right across.
Like a pulse width modulator?
It's like a pulse width modulated signal, just like he said on the transmission setup. That's all it is. Now, why do they do that? Same with peak and hold when you go back to it. And we'll take the throttle body, for example, first, even though, like I said, this could be used on non-throttle body as well. Throttle body was nothing more than a big glorified carburetor with an injector on it, right? What's the pulse width, excuse me, what's the pulse width on a fuel injector at idle on throttle body? Anyone ever look at it? No one knows? It's very little. It's less than a millisecond, isn't it? Not a lot of time. That injector has to come on real quick, right? Because they need to constantly spray. There's a throttle plate right under it. Then it depends on the amount of time as you open it up. Okay? So at idle, they don't need a lot of time because you see it going, you know, years back you used to take your timing light and see if it was spraying down there good, right? It's pretty quick. So what they want to do is get fuel in there quick. Same reason why they put a lot of amperage in it. Why? They got to open this thing up quick. It shuts off. Open it up quick. They don't have time like on a multi-port unit to say, okay, fire and order 184366572, open that one up, close it, let's open the other one up, we'll leave it open a couple of milliseconds, not a problem, right? 4 or 5 milliseconds, some of them depending. So here, they do the same thing. They use a lot of amperage to get the current flowing, to get that injector pintle to overcome the high fuel pressure. They use higher fuel pressure, higher volume pumps in performance vehicles, don't they? So if we overcome that high pressure, high volume, we open it up quick. Once you have it open, it stays there. The valve, I mean, if you actually probably looked at the pintle, it would just do. It would move real quick. It would be real little movement, and the fuel would be spraying in there. Does that make sense to everyone? Any questions on that? Now, here you get to see voltage coming down on a saturated drive, a normal saturated drive injector, and amperage. My amp clamp is set to 50 millivolts per division. So that means my zero line is right there. Okay? I zero my amp clamp, dial it in or pressing the button, make sure the jaws are good, make sure my battery is good. And like I told you before, if your battery's not good, you're looking for a big problem. If the jaws are dirty and so on, you're looking for a big problem. Put it near the alternator, looking for a big problem. It's not rocket science. Make sure you're all set up correctly. When I did this, just think of this. This same picture would be stuck in this one box. Because what's this telling me? That's a half an amp, that's 1 amp. It comes up and holds at about 1 amp. If I got to look at it in a small box, I don't know about you, it just gets tough to see nowadays. If you got maybe one of the blow-up scopes, you can do it. But you could do this on any scope. Remember what I told you? I'm going to give you bits of information you can use on every scope. You take it and you lower the voltage calibration for it. By doing that, you make the picture bigger. We could then see, in this case, that pintle hump is somewhere where? If you see how many boxes you got, 1, 2, 3, 4, 5, 6 and a half, and a pintle hump is at 1, 2, about 3. Somewhere near 50%. Is it good or bad? Maybe on that car it's good. Remember, don't be so bent into every pintle has to be 50 or 60%. Play the matchup game. If you match it up to the known good on the vehicle, Bingo. If you change injectors, here's one thing I got to say. You know, two of our sponsors we have, one is Lender Technical Service, Jim Lender and his injectors, and the other guy in the back there is Injector Perfector right in Rockland County, Jim. Okay. The best thing to do if you got an injector problem is change all of them. Yes, it's expensive, but come on. How many of you guys are wearing two different shoes? I don't know about you. I got two of the same sneakers on here, and I bet there's no one in here with two different ones on. And if you had a ballpoint pen, I used to do this to my customer, click it. Let's say an injector opens 2 milliseconds, okay? How many milliseconds make a second? 1,000. That means 500 times in a second that little pintle was going up and down. 500 times in a second, you got 60, 70,000 miles plus on this car, maybe 170. You're telling me you're going to change one injector? You think it's going to spray the same as the ones that have been going up and down so much? I think not. That makes sense? So do yourself a favor and do the customer a favor, and especially since we're dealing with emissions, right? We're an emission state in New Jersey, just like in New York. Not only the dyno, but the mill light. The mill light's going to see something as well, isn't it? Yeah. So misfires, a lot of times we think only as ignition or maybe a crank sensor. Could be the fuel injector causing it. Remember that example I said earlier on tonight? The P0303 and 305 on that article I wrote? That had a misfire code. That's why that vehicle was being fixed. So please think about that. Any questions on it? Comments? Okay, a couple of more slides, we'll get you out of here. Now, one of the things that we like to do, Rich and I are having the guys in the class actually build the transducer. Do you know what you're looking at here? How many of you guys have ever done this? You know what this is? That's either cranking or running compression. Remember I showed you earlier on that Fluke made the square bar. I told you you need to check the mechanical condition after the battery and the AC voltage. Now, you should all take your scopes, whether it's a Modus, a Genesis, a Fluke, what was the other one we did there? The Pico, the E's, the Bernie scope, and do this. Couple your scope to AC volts. Go to the battery. Red lead, black lead. Disable fuel. You're going to have to set up your scope. Each scope's a little different. You crank it over. You're looking for these voltage heights to be about the same. When you see something low like that, that's about 15% different. Guess what? Now you need to trigger off something. What do I mean by trigger? Just like taking the timing light, going to number one wire, you're going to take something, go to the fuel injector on number one, go to ignition. That way, if it's 153624 or 123456, whatever, you know what cylinder's the problem. Relative compression or cranking compression is not going to tell you what the actual compression reading is. But let's face it, if the engine is equally worn, unless it's running like dog duty, do I really care if it's 125 or 130? Who cares? You're that anal, take a spark plug out, you know, make sure the engine's hot, disable the fuel, open the throttle, 4 bounces of the needle, see where you're at. Now, everything on that cylinder that you just said that was number one, maybe that's 130 pounds. The rest of them are somewhere in that range. I get paid to diagnose problem cars that come in. Someone like John goes around driving, or Teddy or Nick, they drive to shops, right? They got to be real quick to do it. You want to be real quick to do it. You want accurate results. If everything is okay, you don't need to go pulling plugs out. You don't need to go burning your arms underneath or pulling something out that, you know, Murphy's Law, you're going to break it. There's going to be a problem. You need to know how to do it. Does that make sense? And then running compression. You can't get 5 pounds of crap out of a 1 pound bag. It's going to overflow and spill out all over the place, right? What you need to do with running compression is you need a transducer. The transducer in this picture just happens to be a Fluke one. Snap-on makes one. Other companies make them. Okay? Bernie, you heard last month, is coming out with some he's making. Okay? Or what Rich and I have the guys doing, we're going to give them a good GM map sensor from GM, not some other ABC brand, because the calibrations on them are screwy. We're going to take something from Radio Shack, a 5-volt converter, and take a 9-volt battery, and this guy is going to have himself a transducer so he can do running compression and see if there's a problem on the car when it's running. Sometimes cranking compression is good, but you got carbon buildup on a valve. You're not going to know that. Okay? You got a clogged exhaust. You may not know that. Well, we're going to know that by doing this. And this is stuff that you guys can do, whether you have a Vantage. I've had a lot of guys in my class with the old Vantage, graph and meter. You can do it. You just got to sometimes know and have your diagnostic routine printed out. You know, just like that big box scope I keep going back to. It forced you to do check the battery, right? Check the starter, check the alternator, check the gas readings coming out of the tailpipe. You checked all this stuff. Guess what it told you? What was good. And sometimes it told you what was bad. At least if you know things are good, you don't look over there. But if you don't test, you're guessing. And one of the old mottos from Sun, remember Sun Electric? We test, not guess. Okay, but so many people guess, I guess, and they don't test. Becomes a problem. You got to really be careful and make sure you look at everything very carefully. Any questions on this? Anyone ever do this? By the way, if it has a good GM map sensor right on the car, all you need to do is go to the middle wire, couple your scope to AC, and I told you to go to the battery, and any scope. Again, we're not talking a specific brand of scope here. Notice I use the generic scope like I have in my Labscope book. That way people don't get bent. Any scope is what you can do it on. Okay.
And this is called a transducer, this something?
Yeah, that's a transducer. This is my old one actually, just colorized. That's a PV500, no longer made by Fluke. You can do vacuum, pressure, fuel pressure with it, tranny pressure. They make a PV350 now. And basically that means it can go up to 350 pounds or more. The 500, you do 500 or more, but they rate it for accuracy. Again, when you get into higher numbers, it's like an amp clamp. When you're in the higher numbers, who cares? You want a low current clamp that is probably in a range of about 20 milliamps accuracy, so it's not all over the place. You know, you're not getting something burning the computer out. When we talk about air-fuel wide range sensors, there's currently no inexpensive clamp out, or one that's reasonably priced, that you can buy and measure a negative 3 milliamps or 3 milliamps. So the amp clamps we have, you can't use it on that. You got to use your meter, because it's that much more accurate. Does that make sense? So unless you want to spend thousands of bucks and buy one of those, Fluke bought some amp probe company. They said they may have something coming out that would be reasonably priced. Bernie said he's working on something. I think in the future, like everything else, computers have come down, everything comes down. Keep your eyes open. For now, you need a good amp clamp that you could purchase for a reasonable price. You need a good scope. You should know what your scope is capable of doing or not doing. You should know not to put your scope, meter, probe, power probe on any high voltage wire. I told you about that one guy up in New York. He put a power probe on an orange wire, it blew up, and he's partially blind in one eye. Okay? Sometimes people don't know what they're doing. Lucky high voltage usually knocks you back. Know that 60 volts will stop your heart. Okay? If you're going to test anything, make sure you have the right stuff. Does that make sense? Information is key. NASTF, National Automotive Task Force. Like I said, I had the training committee. I finally got myself a co-chair so someone else can do some work besides me. I welcome her on board. And people like John that came out, and Teddy and Nick, you know, we meet all the time. The people on the board, not only at our 2 annual meetings that we have, or semi-annual meetings that we have, but we're trying to help you guys get information. Right now, on the training committee, this means what information is available to you or not. 6 to 8 companies, I forgot the exact amount, complied. I know it's Toyota, Lexus, you know, Scion, Honda, Acura, I think it's Jaguar, Range Rover, and maybe one other company that actually has information up to date. The stuff on the website will be changed, has a new logo coming, all that stuff. If you guys don't use these manufacturer websites or put in any complaint forms, you're going to lose any information you're ever going to get. The work is going to keep going back to the dealer. So you need the right information. Not that Mitchell and AllData, both phenomenal products, but sometimes you will need the manufacturer information. So make sure you're active and very forceful in filling something out. If you see something you don't like, put a complaint form in. You also could see when scan tool companies are giving you a scam. You want to know what's available from the OE manufacturer, go to the scan tool matrix there. That's the tool committee from ETI, Equipment Tool Institute. They'll tell you what they gave. For argument's sake, a lot of people get mad on a Viper. Oh, there's no ABS or airbag. Chrysler doesn't even put that out to put in their own factory tool. So sometimes you may not be aware of it. If you go there and see the information wasn't given from the manufacturer, well, how's the aftermarket going to put it in their tool? It's not available. They're not putting it out on their data line. Why? Number one, they don't have to because it's a production vehicle that's very small. So keep that in mind as well. IATN, good resources. Use PCMs, recms.com, good resource there. Don't forget my website, www.attsttraining.com. And if you're interested in more training, let me know. If you have any questions, does anyone have any questions we didn't cover? Amp clamps, anything else?
Yeah, you talk about like doing ripple now, you go AC coupling, and sometimes you have your option of AC coupling, DC coupling, ground coupling. What's the
AC is meaning you want to test AC voltage. It's more accurate. Even though you may get an AC signal on DC, you're just looking at the AC signal. So that's why you would want to couple it to AC.
when would you use ground coupling?
Ground would get into not what we're using here in automotive. You wouldn't bother with that, but that's on some of the electronic scopes. So like your Fluke had that, right? Tektronix has it. Usually on that. Any other questions? All right, gentlemen, don't forget next month, Dave Scala. Thanks for coming out. Fill out your evaluation sheets. Have a great day.